Hello, everyone. Am I live? Are you people there? Let everyone join. People are still joining. We will start in a while. Let me open the Telegram also. Yes. So can you tell me if I'm clearly visible, audible, everything is good to go? Can someone confirm? Karthik, Aditya. If I'm clearly visible as well as audible, you can see my screen also. Hello, Leah. Am I live? Can you people see me? Can you please respond in the chat? Okay, thank you. Thank you for responding, everyone. Thank you so much. So can we continue? We will continue in 10 more seconds. Students are still joining now. Okay, all good to go. Great, great, great. Okay, so let me start. So we have started community medicine in the morning. We have started the chapter health and disease. We have finished it, the complete health, the complete disease, all the indices we have completed. We have started chapter number 2, nutrition, and we are continuing that. Okay, so we have already covered in nutrition all about the carbohydrates, everything about the protein, everything about the fat, and now it's time to start the minerals. Apart from that, we have seen the reference Indian male, reference Indian female, the requirements, and all that. Okay, now I will be starting with the minerals. So there are 3 important minerals in your syllabus: the iron, the iodine, and the fluorine. We will take all 3 one by one. You get questions on them. So first, let's start with iron. For teaching you iron, I would like to draw a diagram for you. You know, how does normal iron get absorbed in human body? So let me draw a digestive system for you. A rough diagram of a digestive system I would like to draw it for you. So whatever iron we eat, okay, so iron is present either in vegetarian diet or it is a non-veg. Okay, so in the vegetarian diet, the iron is present where? Just a second, let me complete this diagram. Okay, so whatever iron we eat now in the veg or non-veg, in the vegetarian diet, iron is present either in green leafy vegetables like spinach, it is present in jaggery, gud में present होता है, पालक में होता है, हरे हरे सब्जियों में होता है, green vegetables. Okay, in the non-veg it is present in the meat. So whatever iron we eat, it is in ferric form, Fe3 positive. In pathology also you study the same, right? Now it will go inside, 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 inside. It will go in the intestine. Let me draw the cell of the intestine. This is the cell of intestine. You can see this is the cell of the intestine. Now I want the iron to get absorbed through the cell, go inside the cell, and after that go in the blood vessel. It will absorb and go in the blood vessel. For that, 2 transporters are required. One on the luminal side and one on the basolateral side. So 2 transporters are required on both the side of the cell. Can you see? This is a cell. I want you to appreciate this cell, the intestinal cell, the enterocell. So I want iron to get absorbed through the cell and reach from the lumen of the intestine into the blood. So this cell will do the absorption. So 2 transporters are required, you can see. So the luminal surface transporter is known as DMT, divalent metal transporter, DMT. And the other transporter on the basolateral side, this transporter, you can see one more transporter, it is known as ferroportin, right? Now, as the name indicated, it is DMT. What is D? Divalent. It will not take ferric iron. Whatever iron we are taking, it is Fe3 positive. So first we have to convert Fe3 positive to Fe2 positive. Then only it will get absorbed. So convert Fe3 positive to Fe2 positive. This conversion is done by HCl, hydrochloric acid present in the stomach. It converts ferric iron to ferrous iron. Can you see Fe3 positive get converted to Fe2 positive? And now it will go inside the cell. It will go inside the cell. You can see from the lumen of the intestine, it is going inside the cell. After going inside the cell through ferroportin, it is going in the blood. Once it is going in the blood, the ferroportin again oxidize it and it again convert it to Fe3 positive. So whatever iron we take in diet is Fe3 positive. Whatever reach in the blood is also Fe3 positive. Only for absorption purpose, it is converted to Fe2 positive. How many of you got it? Say something, how many of you got it? Okay, so this is how the absorption of the iron takes place, right? Now, once the iron reaches in the blood, iron don't walk. Iron require a transporter to sit. Hana, the scooter, I call it scooter. The scooter, the car of the transporter on which it sit and move here and there in the human body. So who is the transporter? T for transporter, T for transferrin. So transferrin is the transporter, the scooter of the iron. On one scooter, how many people sit? 2 people sit. In the same way, on one transferrin, two molecules of iron will sit. And transferrin will carry. It is carrying the iron everywhere. FP is ferroportin. Okay, it is the name of the receptor, name of the transporter. Okay, So transferrin. Transferrin is the transporter of the iron. On one transferrin, 2 molecules of iron sit and it transmitted throughout the body. Now you tell me, where is iron required in human body? Where should I carry it? The transporter is carrying the iron to which portion, to which organ? Iron is required for synthesizing heme of hemoglobin. Only one purpose, heme of hemoglobin. So the RBCs are present in the bone marrow. I mean, the RBCs are synthesized in the bone marrow. So the precursors of the RBC, the normoblasts require iron for synthesizing hemoglobin. So the transferrin carry the iron. You can see it is carrying the iron to the bone marrow. And these all precursors will take the iron and convert it into hemoglobin, heme of hemoglobin. The remaining extra iron will go in the liver after that. And it will be stored in the liver in the form of the ferritin. So ferritin is the storage of iron. So tell me two things. Who's the transporter of iron? Who's the storage form of iron? I'm sorry, the image is gone. It will not come again. I know I have drawn it. No, it will not come again. I hope you got it. So I'm not drawing it again. I'm asking you the question. Tell me the transporter of iron. And tell me the storage form of the iron. Two questions. Who's the transporter of iron? Who's the storage form of iron? The transporter is transferrin. It's a question. It's a PYQ. And the storage form is the ferritin. Both are questions. Storage form is ferritin. Now, I do not want to draw the diagram again. Okay, in short, I will draw. I will not draw the GIT. So this is the blood vessel. This is the bone marrow. And this is the liver. In the blood, it is coming from GIT. Okay, you can see a rough diagram I'm drawing. Okay, you can see, so whatever iron we are eating, it get absorbed, it is reaching in the blood. In the blood, it is sitting on its transporter, that is transferrin. It is first carrying it to the bone marrow. Whatever extra left, it is going in the liver and getting stored here in the form of the ferritin. So this one is ferritin, we all got that. Now imagine from today, I stop eating iron. Yes, I'm not eating iron in the diet. For example, any human not eating. Maybe the person is very poor and cannot afford that. Maybe the person is sick and cannot eat it. Maybe the dentition is a problem. The person is old and don't have the teeth. Whatever is the reason, the person is not eating the iron in the diet. So from today, I will have anemia, iron deficiency anemia. No. You will say, ma'am, it's okay. Now you have the backup. Who's the backup? The ferritin, the storage form of the iron. So actually, iron is required by the precursors. These are the precursors. The precursors of the RBC, they require iron for the synthesizing hemoglobin. Now, if it is not coming from the intestine, if iron is not coming from the intestine because person is not eating it, not absorbing, not present in blood, not coming from the intestine, then it will come from the liver. Liver will give it to the bone marrow. It's okay. The backup is there. So till 1 month or 2 months, the backup is present. It will keep on giving, and the hemoglobin gets synthesized. There is no problem in that, right? Once there is a point will come when ferritin is also zero. After that, the RBCs which are formed, that will have less hemoglobin or no hemoglobin, and person have microcytic hypochromic anemia. Okay, so tell me the most sensitive indicator of iron deficiency anemia. Whenever the person have IDA, iron deficiency anemia, the first thing which will fall is what? First hemoglobin is falling. The hemoglobin is falling or first ferritin is falling? Of course, first ferritin will fall because ferritin is the backup. It will keep on falling. One point when ferritin is zero, after that hemoglobin start dropping. So first ferritin will fall. So ferritin is the most sensitive and specific indicator for iron deficiency anemia. So 3 questions, 3 answers. Transporter, storage form, and sensitive indicator. Tell me 3 questions, 3 answers. So first question, transporter is transferrin. You all can see this is transferrin. 1 molecule carrying two molecules of iron. Number 2, storage form, you all can see it's ferritin, it's in liver. And number 3, the most sensitive indicator, the earliest indicator to fall in iron deficiency anemia is again ferritin. Say yes, say no. Say something, respond. These all are questions you get. So iron deficiency anemia, you can measure the hemoglobin, but it's not a very good indicator. You can see the iron in the blood, not very good indicator. The best indicator is the ferritin. Most sensitive tool, the earliest tool. I know. You can see transferrin also. Can we go ahead? So regarding hemoglobin, what are the cutoff? When you will call any person as anemic? So the WHO has given the cutoff. When any male have hemoglobin less than 13, the person is anemic. The 13 is the cutoff for male. When any female, non-pregnant female, the cutoff is 12. For pregnant female, the cutoff is 11. For children, the cutoff is 11. Don't learn for children, just learn for male, female, pregnant female. Learn the cutoff for hemoglobin. Let me ask you a question. There is a person whose hemoglobin is 12.5. Tell me the person is anemic or not anemic. Write down in the chat box. Can you tell me the person is anemic or not anemic? Can you comment? There is a person whose hemoglobin is 12.5. Say the person is anemic or not anemic. I'm asking. Say something, people. Say, I'm asking you. Huh? You will say, ma'am, I can't comment. Tell me the age and gender. Don't say yes or no. Tell me age and gender. Without that, you cannot comment. Now, if I say the person is male, what is your answer? If the person is female, what is your answer? Tell me the cutoff. In male, the cutoff is 13. And in female, the cutoff, non-pregnant female, the cutoff is 12. And in pregnant female, the cutoff is 11. Now apply. 12.5 is less than 13. So yes, the person is anemic. Here the person is anemic, but 12.5 is more than 12 and 11 both. So these females are non-anemic. Pregnant or non-pregnant, both are non-anemic. You got my point, Hannah? So cutoff matters, number one, and male female matters. Okay, got it? So gender matters, and I'm saying this is all for adult. If I say the children, again you have to look for the cutoff. Got my point? Can we go ahead? Yes, you have to learn the cutoff. Got it? Okay. What is the normal daily iron requirement? How much iron should I eat? Anyone should eat. So adult male, it's fixed. It's always 17 milligram per day. All the males should consume 17 milligram per day of iron in the form of the veg or non-veg, whatever. Hannah. But female during menstruation, of course, more iron is required because the female is bleeding. Hannah. Most of the blood, hemoglobin, iron is lost in the bleed. So she requires more during these 3-4 days of menstruation. So during menstruation, females should eat such food that is containing more iron. Hannah. So she require, instead of like male 17, she's requiring 31. During pregnancy, the female required 35. And during lactation, the female require 21. Hannah. This is not during menstruation. I mean a menstruating female, a young female, a menstruating female. And anytime throughout the month, she required 21 because she bleeds every month. Okay. So this is the iron requirement for a female. See, compare with male. So female require more iron, Hannah, at any time. Menstruating female also, lactating female also, pregnancy also. You have to learn that. This is all in milligram per day. Hannah, don't learn for infants and adolescents. Learn for male and female. This is the daily requirement. Now there is a program run by the government which is known as National Iron Plus Initiative. Hannah, National Iron Plus Initiative, NIPI. National Iron Plus Initiative. We see in India, iron deficiency anemia is very common in India. Hannah. So government is giving free iron and folic acid tablets. Iron and folic acid tablets are supplied free of cost to the beneficiaries. You will say, ma'am, who are the beneficiaries? There are 6 beneficiaries. I will cover that in National Health Program. Hannah, it is given free of cost to all the beneficiaries. There are 6 beneficiaries here. Hannah, we will give iron folic acid tablets free of cost to them. Anyways, so we are done with iron. The important points we have seen. Okay, now read the question, tell me the answer. Best test to detect the iron deficiency anemia in a community. What is the best test, sensitive test, earliest test? Is it serum transferrin, ferritin, iron, or hemoglobin? If I want to test one and comment whether the person is anemic or not anemic, what is the best test? Don't go with hemoglobin. Hemoglobin fall later. Before that, ferritin will fall. So ferritin is the answer. This is the reason. I know why ferritin is the answer. It is the storage form. सबसे पहले ferritin कम होना शुरू होगा. उसके बाद ये और ये भी कम होंगे later on. But earliest is ferritin. So correct answer is B, and I hope you all people are right. Okay. The next question. Best test to detect, an adult pregnant female is termed as anemic when her hemoglobin is less than what? Tell me the cutoff for pregnant female. Is it 11 gram, 12 gram, 13 gram, or 14 gram? I'm asking for a pregnant lady. What is the cutoff for anemia? When the hemoglobin is less than what, you will call the lady is anemic. Yes, Tanu, absolutely right. Yes, Sanya, very good, very good. You all are right. The correct answer is 11. For pregnancy, the cutoff is 11, and you all are right. If I change the pregnant to non-pregnant, what is your answer? What is your answer? Pregnant to non-pregnant, what is your answer in that case? Can you please tell me answer in that case? Would you like to change? Of course, in that case, answer will become 12. And if I change to male, male cannot be pregnant, of course. It's a simple male. So in that case, answer will become 13. So if I change the question, answer will change accordingly. We are done with iron. The next mineral, important points regarding that is the iodine. Let's start with iodine. Okay. What is the iodine? Body stores iodine. In the body, 50 milligram of iodine is stored. The blood level is 8 to 12 microgram per deciliter. Maximum iodine is present in seafood. Do you eat seafood? By seafood, I mean the fishes, the crab, all the seafood. Or cod liver oil. Cod liver oil is cod is a fish. So inside the liver of the fish, the oil, that is maximum iodine is present. Okay, seafood. It's a question. Seafood is the best source of the iodine. Seafood is the best source for iodine. Requirement daily. We all require 150 microgram per day. It is not different in male and female, है ना? It is always 150, but in pregnancy and lactation, instead of 150, it's 250. है ना? Please write down all the normal requirements at one page. Iron का कितना, protein का कितना, carbs का कितना, इसका कितना, है ना? Like that. ठीक है? Let's come on iodine deficiency. So let's come on iodine deficiency. Okay, iodine deficiency disorders. These are known as IDD, iodine deficiency disorders. What happens in all age group? What happens in fetus? What happens in neonate? What happens in children? What happens in adults? We will see one by one. In all age group, goiter is common. Whenever iodine is deficient, goiter is very common. Can you see this is goiter? Anna, you know why goiter occurs. So iodine is required for the formation of thyroid, T3, T4 hormones. You know how T3 and T4 are formed inside the follicular cells of the thyroid gland? You all know, I guess, we have a thyroid gland. Anna, it is having two lobes. It is present in the neck. The two lobes are connected by isthmus. Inside the thyroid gland, we have follicular cells, inside which the thyroid hormone is synthesized, T3, T4. For their synthesis, iodine is required. Now, if iodine is deficient, T3, T4 will not form. So T3, T4 will be less. And due to the feedback from the pituitary, TSH will be more. So T3, T4 will be less, TSH will be more. The disease is known as goiter and the gland will swell like this. Hai So in all age group, the iodine deficiency leads to goiter and hypothyroidism. That is the same thing. T3, T4 will be less because iodine is not there. Hai And radiation susceptibility. In fetus, it will lead to abortion. Hai You can see the abortions are common. Abortions. If any pregnant lady have iodine deficiency, the lady can have abortion. The lady can have stillbirth. The lady can have congenital anomalies in the fetus. In a neonate, it is infant mortality. Infant mortality is common in a neonate. Hai na? Endemic cretinism. Can you see? This is cretinism. In children, the IQ is low. The IQ is low. The person who is having iodine deficiency in childhood age, the IQ is low. Hai na? Submental. The person can be mentally retarded. In adults, again, it's impaired mentation and poor performance. So these are the iodine deficiency disorder. Got it? Say yes or no. That is iodine deficiency disorder. Just a second. Let me see. Okay. Okay. You tell me, for iodization, from where we get the iodine? So you told me, ma'am, iodine is present maximum in the seafood. But I am a vegetarian. I don't eat seafood. I don't eat fish. So will I have iodine deficiency? Will I have goiter? Huh? Will I have? No, I will not have. Because along with the seafood, iodine is also present in the soil. Iodine is also present in the soil. And I'm vegetarian. So I eat the fruits, vegetables. They all are there coming to me from the plants. These are the plants. So iodine is present in the soil. So whatever food we eat, the fruits, vegetables, it also contain a little bit of iodine coming from the soil. Coming from the soil, it is present in the food, whatever we eat, the veg food. I mean the fruits, vegetables, the green leafy vegetables, they all contain a little bit of iodine. Actually, it is not present in the food. It is present in the soil in which they are grown. Now, there are certain areas, especially, I mean the hilly areas where soil is deficient of iodine. The hilly areas, jitna ऊंचाई pe hai na, the hilly areas, the soil don't have iodine. So people living at the hilly areas, someone living at the Himalayas, someone living at hilly areas, whatever, hai na? So hilly areas soil don't have iodine. So whatever food they are eating, it don't have iodine, hai na? The vegetarian people, so they can have iodine deficiency. So iodine deficiency is very common in hilly areas. This is the reason. This is known as endemic goiter they have there. Now to prevent this, what should we do? We should add the external iodine. We should give the external iodine. Where we give the external iodine? We should give external iodine in something which is eaten by everyone. Tell me a thing which is eaten by everyone. Salt. Salt is something, namak. Everyone eats it. Whether the person is rich, whether the person is poor, whether the person is a male, whether the person is a female, whether the person is a child, whether the person is an adult, whatever, whether the person is Hindu, Muslim, Christian, whatever, Hana, all the persons eat salt. That's why government has decided to iodize the salt. I know salt is something that everyone eats. So in this way, we can provide iodine to everyone. All the people eat salt. We should purchase iodized salt from the market. In the market, iodized salt is available. Iodized salts are available. It is written on the salt packet, whatever brand you are using. So Tata, Ashirwad, many brands are available. So iodized salt we should use. It contains iodine. It is already fortified with iodine. So salt contains additional. Salt is NaCl. But along with that, additional iodine is provided, especially in the hilly areas. It's very required because their soil is deficient and the person can have goiter. So we are preventing it. So we are doing the fortification. So which level of prevention is it? The food fortification, iodization of salt, is it primordial, primary, secondary, tertiary? The people who are with me since morning, they know what I'm talking about. The levels of prevention. Tell me, iodization of salt is which level of prevention I'm asking? So the risk factor is present. The soil is deficient of the iodine, but goiter still doesn't occur. So risk factor present, but disease doesn't occur. So the iodized salt is a type of primary prevention. Yes, all the food fortification is a type of primary prevention. So government does that. So how much iodine government add in the salt? It's 30 ppm at the point of production. So salt is produced in some factory. No, there may be a factory which may be producing some salt from the marine water. I know marine water se salt banta hai. I don't know the mechanism of the process, but at the point of the production, we add 30 ppm. ppm is parts per million. You have to learn 30 ppm of iodine in the salt. Hana? Gradually it evaporates, it's lost. So till it reaches the consumer, it should be minimum 15 ppm. Hana? It should be minimum 15 parts per million. Okay, got my point? So at the time of the production and at the time of the consumption, tell me the minimum iodine which should be present in the salt according to the government guidelines. It should be 30 ppm at the time of the production, and it should be minimum 15 ppm at the time of the consumption. This is the iodine. This is the iodine we are adding in salt, NaCl salt. How much iodine we should add? So at the time of production, it's 30 ppm. At the time of the consumption, at least 15 ppm to bacha hona chahiye. It should be remaining in that. So please learn 13 and 15. Everyone, both are PYQs. Apart from that, if you don't want to take iodized salt, no worries. Iodized oil is also available. Take the injection of that. And an intramuscular injection will be given in the deltoid or in the buttock. Every 4 years, one injection. You don't have to take iodized salt every day. Once every 4 years, providing protection for 4 years. Iodized oil, injectable intramuscular injection is available, right? Or else nowadays, double fortified salt we use. It is known as double fortified salt, DFS, also known as twin fortified salt. Double is twin. So we take the salt NaCl. We add two things in that, iodine and iron. Because government is saying, yes, goiter is common, but iron deficiency anemia is also common in India. So why don't you fortify the salt with two things? Iodine to prevent goiter and iron to prevent anemia. Okay, see how much government is doing for us. Okay, so here 1 gram of salt, 1 gram of NaCl contain 40 microgram of iodine and 1 milligram of iron. This is known as twin fortification. The twin fortification concept is given by NIN Hyderabad. National Institute of Nutrition, that is NIN. NIN Hyderabad has given this concept, the twin fortification. So what I'm telling you, double fortification salt, yeah, twin fortification salt. What does it contain? It contains NaCl. Of course, salt to hai, no? So it contains 1 gram of NaCl. It additionally contains two more things. 1 gram of NaCl contains 40 microgram of iodine and 1 gram of iron. 1 gram or milligram? Let me check. It's 1 milligram. I'm sorry. 1 milligram of iron. This is known as twin fortification. How many of you got it? How many of you got it? Yes, I will provide the annotated version in the end. Okay. Can we go ahead? Okay. So please learn that. Please learn. Can we go ahead? Yes. So this is the thing. And DEC medicated salt is also available. Okay, you can leave it. DEC for the treatment of the filariasis. Anyways, so iodine deficiency disorders, IDD. IDD are very major. Sometimes it can be a major public health problem. Okay, IDD. IDD reduces the IQ by 13 points. It can reduce the IQ. Global Iodine Deficiency Day every year, 21st October. It will come the next month. August, September, October, after 2 months. It will come 21st October. Every year, we celebrate IDD. Whenever it will come, the messages will come on your Instagram and everywhere. Okay, so today's IDD, Iodine Deficiency Disorder. Okay, 21st October every year. And if the iodine uptake is less than 20 microgram per day, the person will have cretinism. So these are the important points you have to learn. The last thing in the iodine you have to learn very thoroughly. The last thing which you have to learn. Tell me there is a community. I'm not talking about a person. There is a community. There is a geographical area. The community can be a country, can be a city. For example, let's take a city, Delhi. It's a community. So if I say any community have IDD or do not have IDD, how to judge that? How to judge? Now, if it is having the community have IDD, the government will take some actions. They will give the fortified salt and all, whatever. So how to judge whether the community is having IDD or do not have IDD? There are 4 criteria. How many criteria? 4 criteria. See all the persons, how many of them have goiter? How many of them have I'm sorry. The community here, IDD is eliminated in any community. What are the criteria for that? When you will say that in this community, the IDD is already eliminated. You know the definition of elimination I told you. In the elimination, the agent is present in the environment but cannot enter inside the host body. I told you, control, elimination, eradication. Have I told you? So for example, let's take a community, any community. It can be Delhi, it can be India. So when I say the IDD is eliminated in that community, there are 4 criteria. When from the total 100% population, less than 5% people have goiter. Goiter is present only in less than 5% of the people out of 100. Anna, I will say the IDD is eliminated. Anna, number 2, if in the urinary iodine is less than 100 microgram, this is severe iodine deficiency. It is present only in less than 50% of the people. Anna, urinary iodine less than 50 microgram, it is present only in less than 20% of the people have this. Anna, and the house, total Indian houses, Anna, how many houses uses iodized salt? Iodized salt. More than 90% of the people are using iodized salt. Then I will say the IDD is eliminated from the country. So these are the 4 criteria. The number of the people who have goiter is less than 5%. Okay. The number of the people who have urinary iodine less than 100 microgram or urinary iodine less than 50 microgram. Less than 100 microgram, less than 50% of the people. Less than 50 microgram, less than 20% of the people. And how many houses use iodized salt? More than 90% of the houses uses iodized salt. Then I will say the iodine deficiency disorder is eliminated from that community. Say yes. How many of you got it? These are the criteria you have to learn. Can we go ahead? We are done with iodine also. We are done with iodine also. Say yes. I know rectification is too much, but I'm making it easy. Na? Don't try to mug it up. Just learn the concept so that options will be in front of you. You don't have to create an answer कि IDD elimination criteria, लिखो 4 criteria बिना देखे. ऐसा कोई question नहीं आएगा. It's not subjective exam. It is an objective exam. The 4 options are in front of your eyes. You have to just pick it up. है ना? So if you have looked it once ना, don't try to mug it up कि चारों बिना देखे eyes close करके बोल रहे हैं. Don't try. It will be in options. Now you can easily pick it up. You can easily pick it up. And that's it. This is the way you should learn. If you try to mug it up everything and like closing your eyes, and if you try to murmur everything, now you will become mad. Anna, so don't try so. PSM is a big subject. Okay, read the question and tell me the answer. Twin fortified salt contains what 2 things? Iodine and fluorine, iodine and calcium, iodine and iron, iodine and chlorine. Very easy question. Be fast, huh? I don't have patience. Fast. Yes, very good, very good. The correct answer is C, iodine and iron. Tell me how much? So 1 gram of salt contain how much iodine, how much iron? I'm asking. Iodine is 40 microgram, iron is 1 milligram. They both are present in 1 gram of the salt. This is how you have to learn. This is TFS, twin fortification salt, also known as double fortification salt. Who has given this concept? The NIN Hyderabad. It's also a question. National Institute of Nutrition, Hyderabad has given this concept. Okay, yes, 41 shake, it's good, but learn the unit also. 40 is microgram, 1 is milligram. You have to learn that also. And these both are present in 1 gram of the salt. See the units. Okay, so coming on the next question. As per WHO guidelines, iodine deficiency disorders are endemic in a community if the prevalence of the goiter is more than. If the prevalence, I told you now, how much goiter should be there to say it eliminated. If the prevalence of the goiter is more than 5%, we will say it is endemic in that community. If it is less than 5%, it is eliminated. So you have to learn the percentage also. Coming on the last mineral, that is fluorine. We are done with the iron. We are done with the iodine. The last mineral is fluorine. The third and the last mineral here we have to cover is the fluorine. So let's start fluorine. Where is fluorine present in human body? 2 things, teeth and bone. So in our teeth and bone, fluorine is present. Hannah, from where we get the fluorine? We get the fluorine from drinking water. Water is the source. So what is the ideal fluorine content of the water? The ideal normal fluorine content of the water is 0.5 to 0.8 milligram per liter. Please learn. It's 0.5 to 0.8 milligram per liter. Hannah, and it is also present in seafood, cheese, tea. Right? See the range. 0.5 to 0.8 is such a narrow range. Below 0.5, deficiency will occur. Above 0.8, excess will occur, disorders will occur. It is a bi-edged sword. Fluorine ki deficiency also causes disease. Fluorine ki excess also causes disease. Both cause disease. It's a bi-edged sword. That's why I call it double-edged sword. डबल एजेड है ना, दो धारी तलवार है, कम हुआ तो भी मुसीबत, ज्यादा हुआ तो भी मुसीबत. So please learn the normal range. It's 0.5 to 0.8 milligram per liter or ppm, one and the same thing. How many of you got it? So in the water, this much of fluorine should be present. This is the recommended level. Recommended level, है ना? We will talk about two things. First, deficiency, then access. What happens if it is less than 0.5? What happens if it is more than 0.8? If it is less than 0.5, dental caries. Only one disease, dental caries. दांत सड़ जाएंगे, हिंदी में कहें तो. So dental caries are there, है ना? That's why all of our toothpaste contain fluorine, है ना? Read it. The toothpaste, maximum toothpaste contain fluorine. But the area where the water already contain excess of fluorine, na, use the toothpaste without fluorine because water already have excess of fluorine. Say yes, है ना? So dental caries are there. If the fluorine deficiency is there. Now what about fluorine excess? What about if it is more than? This is when it is less than 0.5. If it is more than 0.8, the disease is known as fluorosis. Deficiency is dental caries and excess is fluorosis. There are three types of fluorosis. Dental fluorosis, skeletal fluorosis, genu valgum. I will tell you all three. Dental fluorosis occurs, है ना? Here you can see there is mottling of the tooth, especially the incisors of the upper jaw, not lower jaw. है ना? The fluorine, the excess fluorine will deposit. Dental caries अलग था. The deficiency leads to dental caries. Excess lead to dental fluorosis. Got it? Their caries were there, and here fluorosis. The fluorine get deposited in the upper incisors, and it will give yellowish appearance to the tooth. है ना? It is known as mottling of the dental enamel. Okay, it will occur when the concentration is 1.5 milligram per liter instead of 0.8. It is 1.5, है ना? And it is confined to the permanent teeth. The second is the skeletal fluorosis, when the concentration is 3 to 6 milligram per liter, है ना? And at 10 it will lead to crippling, है ना? पूरा cripple हो जाएगा, paralysis, crippled, है ना? And finally genu valgum, more than 10 it will lead to genu valgum. What is genu valgum? You can see this is genu valgum, the knee lock, the knees get bind with each other, है ना? They cannot be separated. Genu valgum. Say yes, huh? Let me write the summary. Fluorine. Tell me the source. Tell me the source of fluorine. Water. Okay. Tell me the normal concentration. 0.5 to 0.8 milligram per liter. It's ppm. Okay. Tell me what happened if deficiency occur. Tell me what happened if excess occur. Okay. Tell me the name of the diseases. In deficiency, it leads to dental caries. Only one disease. It is less than 0.5 milligram per liter, dental caries. And in excess, the name of the disease is fluorosis. The fluorosis have three things inside that. Dental fluorosis, this was dental caries, this is dental fluorosis. And skeletal fluorosis and genu valgum. Okay, ji, है ना? So dental fluorosis occurs at 1.5 to 3 milligram per liter. This one is 3 to 6 milligram per liter, and this is more than 10 milligram per liter. And this one is at less than 0.5 milligram per liter. You please learn the normal range, and please learn this. So in dental fluorosis, the incisors are involved, upper jaw is involved, and there is mottling. And in skeletal, finally the crippling occurs. Crippling occurs at 10 milligram per liter, and genu valgum more than 10. So I want you to learn this. Learn the normal range. Learn deficiency leads to what? Learn excess leads to what? 1.5 to 3, 3 to 6, more than 10. Please learn that accordingly. Everyone give me a thumbs up if you got it. This is fluorine. And write down, that's why fluorine is known as double-edged. Double-edged sword. The deficiency is also painful. The excess is also harmful or painful. है ना? तो ना हमें कम चाहिए ना हमें ज्यादा चाहिए. हमें कितना चाहिए? 0.5 to 0.8 milligram per liter. How many of you got it? How many of you got it? Everyone, please learn. You get many questions on the fluorine, and students always have confusion. कि dental caries क्या है? Dental fluorosis क्या है? Deficiency leads to dental caries. Excess leads to dental fluorosis. There is a difference between caries. Caries यानी दांत सड़ जाना, है ना? बैक्टीरिया सड़ाएगा दांत को. और excess मतलब fluorosis, दांत में mottling हो जाना. The upper jaw, the incisors have the yellowish color mottling, and it's permanent. Got it? है ना? So what is the intervention you will take? I do not want deficiency. I do not want excess. So what if my water, I'm drinking my water, the government is supplying now. So the water contain less fluorine. What should I do? You should use the toothpaste which contain fluorine. Extra आप ले लो, toothpaste ले लो which contain fluorine. If government is supplying less, it's okay. You take extra in the form of the toothpaste. I guess everybody does the brush in the morning with the toothpaste, I know nowadays. So the toothpaste have the fluorine, there is no problem, the deficiency will not occur, dental caries will not occur. But what if there is a problem, if there is access? The water at my home contain more fluorine. How to remove that additional fluorine? How to remove? In that case, the first thing, use the toothpaste without fluorine, because water already have access of that. Don't give more access. So use the toothpaste without fluorine. Both type of toothpaste are available in the market. Okay, number one. Number two, what about the water which already contain extra fluorine? So you have to do the defluorination of water. Defluorination of water, there is a process known as Nalgonda technique. So let me tell you what is Nalgonda. I will come on Nalgonda now. Nalgonda is a technique in which we remove the extra fluorine from the water. We do not add it. There is no process to add it. ऐड नहीं कर सकते, ऐड तो करना ही नहीं है, यू जस्ट यूज द फ्लोरिनेटेड टूथपेस्ट, लेकिन एडिशनल है तो रिमूव जरूर करना है. दैट इज नोन एज डीफ्लोरिनेशन, नालगोंडा. हाउ मेनी ऑफ यू गॉट इट? So coming on that, Nalgonda technique. What is Nalgonda technique? Nalgonda technique, who discovered that? The Nalgonda technique is discovered by NERI. Who is NERI? National Environmental Engineering Research Institute, Nagpur. Someone from Nagpur? NERI is in Nagpur. NIN is in Hyderabad. You have to learn the institutes also. NIN is in Hyderabad and NERI is in Nagpur. Anna, you have to understand which mechanism. So, twin fortified salt concept given by NIN. Hana, Nalgonda technique is discovered by NERI. These all are your PYQs. Okay, ji. So NERI has discovered. NERI is in Nagpur. And what is Nalgonda? It is defluorination. We are removing the fluorine from the water. We are subtracting, deducing the fluorine from the water. How do we do that? There are 6 steps. 1, 2, 3, 4, 5, 6. Add lime in water. है ना? Lime हिंदी में कहते हैं चूना, इसको चूना करते हैं lime, है ना? So add water. Add lime in the water, number 1. Then add alum. हिंदी पता है क्या? फिटकरी बोलते हैं इसको हिंदी में. I don't know you have heard this word or not. So चूना फिर फिटकरी. Ask your adults, their grandmothers and that age era. They used to do so, है ना? So वो पानी में चूना भी मिलाते थे पहले के जमाने में. फिटकरी. There was no purifiers at that era. Nowadays we have purifier at every home, so we don't bother. And a purifier RO is doing the adjustments. Okay, but they can add the lime. They can add the alum, followed by alum. So पहले चूना मिलाओ, फिर फिटकरी मिलाओ, alum मिलाओ. Okay, then bleaching powder. After that, bleaching powder is added. So add these 3 things. Learn the mnemonic LAB, lab. Lab को add करो. Lime, alum, bleaching powder. उसके बाद do 3 process: flocculation, sedimentation, filtration. Flocculation, sedimentation, filtration. FSF. So these are the 6 steps of Nalgonda. All 6 are in front of you. See, take the water which contain excess of fluorine. Excess of fluorine. You want to remove that. You want to remove that. Just a minute. The chat is, I cannot see the, I can see. Okay. So first add lime, number 1. Then add alum, number 2. Bleaching powder is not shown here. Write down number 3, bleaching powder. Then do flocculation. Then do sedimentation. Then छान लो आखिरी में. Filtration is छन्नी से छान लो. So now all the excess of fluorine is already removed. This is Nalgonda. You get many questions on that. So the summary is in front of you. When normal fluorine is 0.5 to 0.8, please learn that. Normal fluorine is 0.5 to 0.8 milligram per liter. Okay, ji? Anna, if it is less than 0.5, it will lead to dental caries. If it is more than 0.8, 0.8 से more मतलब कितना? More than 1.5, it's dental fluorosis. 3 to 6, skeletal fluorosis. More than 10, crippling fluorosis. How many of you got it? I'm done with fluorine, by the way. Can I summarize the fluorine? You will people help me? You want the revision? Fluorine. Where is fluorine present? In drinking water. What is the normal concentration? Say, very important, very narrow range. 0.5 to 0.8 milligram per liter ppm. Okay, Anna. So tell me this is the normal range. But what if it is less than that? Deficiency leads to what? What if it is excess in that? Excess leads to what? Who will tell me? Deficiency leads to a disease. It is less than 0.5 and the name of the disease is dental caries. Okay, dental caries is there. Okay, and if it is an excess, the name of the disease is fluorosis. There are 3 types of fluorosis: dental, skeletal, genovulgum. All of them are more than 0.8, but kitna? More than 0.8 matlab 1.5 to 3, ki 3 to 6, ki more than 10. Hana? This is where you have to learn. And the important points I already told you in that. Okay, now deficiency ke liye, what is the intervention you take? Change the source of water or use the toothpaste which contains fluorine. But for access, what should we do? Nalgonda technique. Nalgonda technique should be done for access. Okay, ji. In Nalgonda technique, we do the We remove the excess fluorine. It is known as defluorination of water. It is discovered by institute. The name of the institute is NERI in Nagpur. Someone from Nagpur may be knowing that. Otherwise, learn that NERI is in Nagpur. Okay, what they have done? They have said 6 steps you have to do. What are the 6 steps? Take water. Add what in that? सबसे पहले add lime, then add alum, then add bleaching powder. 1, 2, 3. Lab. And then do 3 things. Do flocculation, sedimentation, filtration. You understand what is flocculation? It is precipitation. Sedimentation मतलब पहले precipitate बन जाएंगे पूरे इसमें, पूरे water में you can see precipitate. This is flocculation. Then allow them to settle down. पूरा settle हो जाने दो, है ना? थोड़ी देर don't touch the water, don't उसको हिलाना नहीं है. So everything will settle down. This is known as sedimentation. सब कुछ settle हो जाए और उसके बाद छान लो. Take a छन्नी, sieve and do the filtration. Very easy to understand. Don't learn. पहले क्या होगा भाई? Precipitate बनेंगे, मतलब flocculate बनेंगे, है ना? Flocculation. फिर क्या होगा? नीचे इकट्ठे हो जाएंगे वो. If you don't touch it and leave it standing position, they will sediment, है ना? नीचे gravity से वो चले जाएंगे. And फिर take a sieve and छान लो. Filtration. Very easy, है ना? Okay. Yes. This is how you have to learn. Very good. So that is Nalgonda technique. We are done. So you get many questions on that. Be fast. Tell me the answer. Fluorine level intake required for developing of crippling fluorosis. Is it 1 to 1.5, 1.5 to 3, 3 to 6, or more than 10? I'm asking. Be fast in your answers, please. Crippling fluorosis, I'm asking. Oh, no, Baba. Crippling fluorosis, I'm asking. Crippling occurs at more than 10. No. Why you people are saying 3 to 6? You are getting confused. Crippling occurs at more than 10. Crippling and genu valgum both occurs at more than 10. Yes, the correct answer is more than 10. If I change it to dental fluorosis, your answer will become 1.5 to 3. And if I change it to skeletal fluorosis, your answer will become 3 to 6. But crippling fluorosis or genu valgum, they occur at more than 10. Okay, correct answer here is more than 10. Anyone having any confusion? Okay. The next question, fluorine content in drinking water. Ideally, it should be what? Ideally, normally, reference range, 0.5 to 0.8, 0.8 to 1, 0.2 to 0.8, 0.2 to 0.5 milligram per liter. ये सब liter है. What is the correct answer? Yes, you all are right. Very easy question. I guess this you must say 0.5 to 0.8. Everyone is right. Everyone is not responding, but yet those who are responding, they all are right. Dental fluorosis is best seen in which tooth? In which tooth? Is it central and lateral incisors, central incisors and first molar, first and second molar, or canine? So mottling occurs where? Mottling occurs where? I have shown you the image also, dental fluorosis. Yes? So it is central incisors and first molar. I told you there. Let me show you the image once again. You can see it here. You can see central incisors and the molars. The molars are not shown here. Central incisors and first molar are most commonly affected. Okay. So let's move ahead. The correct answer here is B. Okay, let's come on the next topic, milk. Okay, how many of you drink milk? We drink milk either in the form of the milk or tea or coffee. We consume milk. Okay, so this is milk. So let's study about the milk. Okay, how many types of milk available in the market? We have buffalo milk available, goat milk available, cow milk available, and human milk is the breast milk for the babies, for the newborns, I mean. Okay, so these are the 4 types of the milk available. This is for newborns and this is, again, buffalo milk is for buffalo baby, cow milk is for cow baby, goat milk is for goat baby. It is not for humans, but humans do consume that. Anyways, so, okay, tell me out of the 4 milks which are available, buffalo, goat, cow, and human. Okay, buffalo, goat, cow, and human. Tell me maximum fat is present in which? Sequence of fat, sequence of protein, sequence of carbohydrate. Among carbohydrate, I'm taking lactose. So we have 3 major macronutrients ना, फैट होता है, प्रोटीन होता है, कार्ब्स होता है, और ये सब मिलके देते क्या है? एनर्जी. So tell me the sequence of all 4. Sequence of fat, sequence of protein, sequence of lactose, sequence of energy. है ना? So everything is maximum in buffalo. You can see buffalo, buffalo, buffalo. Followed by goat, goat, goat. Followed by cow, cow, cow. And followed by human, human, human. So everything is maximum in buffalo and minimum in human except lactose. Except lactose. Lactose mein human is number 1. You got my point? You have to learn the mnemonic BGCH. So let me tell you. Okay. So if you ask me, ma'am, what is the sequence of protein or fat or energy? So I will say the same sequence. For all of these, the sequence is B, G, C, H. This is the sequence. Buffalo, followed by goat, followed by cow, or followed by human. But if you ask me, ma'am, what is the sequence for lactose? Here, everywhere the human is the last. Hana? Here, human will come the first. Human will come the first. Human followed by these three. B, G, C. So human followed by same sequence, B, G, C. But human, instead of last, it will come the first. So in breast milk, lactose is maximum. In breast milk of the mother, the lactose is maximum. Everything else is maximum in the buffalo milk. How many of you got it? How many of you got it? So if you have some mnemonic for that, it's good. Otherwise, in the last class, one of my students have told me a mnemonic. Those who understand Hindi, Bhai Goa chalte hain. है ना? If you have some better mnemonic, you can tell me. है ना? So you have some better mnemonic. Bhai Goa chalte hain के अलावा, do you have some English mnemonic so that the student who don't understand Hindi उनको भी याद हो जाए? हाँ? भाई गोवा चलते हैं. ठीक है? So भाई गोवा चलते हैं. BGCH. Unless until you have some better version. Can I go ahead? No, this is the sequence you have to learn. Okay, say yes. Say something. Respond, people, respond. Okay, so this is the sequence of the milk. You have to learn the 4 types of the milk. The buffalo, the goat, the cow, the human. Okay, जी. Beta HCG. Beta HCG तो HCG उल्टा हो गया ना? Beta HCG लिया. GCH हो रहा है वो. Beta GCH. HCG होता तो ज़्यादा better होता. But it is beta GCH. Anyone else? Some better mnemonic? Can we go ahead? Okay, so learn that only. If you can understand this one. Okay, so this is the thing you have to learn. So lactose is maximum in human milk. Otherwise, protein, fat, and energy. Everything is maximum in the buffalo, followed by goat, followed by cow, followed by human. Don't change the sequence. Bhai Goa chalte hain. Okay, be genius in cow house. Good one. Be a genius in the cow house. Yes, this one is good. The one who cannot understand Hindi. Be a genius in cow house. Aditi. Thank you, Aditi. Okay, so can we go ahead? Okay, so what are the method of pasteurization of milk? How we sterilize the milk? The method of sterilization of the milk is known as pasteurization. There are 3 ways to pasteurize milk. What are the 3 ways to pasteurize the milk? You study the same in microbiology also. Holder's method, high temperature short time, HTST method, and ultra high temperature, UHT method. है ना? So Holder's method. The Holder's method, let me tell you. Okay? Okay, Holder's method. Holder's method, the milk is boiled at 66 degree for 30 minutes. That is Holder's method. High temperature, short time. It is also known as flash method. Very important. So I don't have 30 minutes. I'm very busy, right? So instead of 66, I will do it 72. So instead of 30 minutes, it requires only 15 seconds, not 15 minutes. See, kahan आधा घंटा, kahan 15 seconds. So drastically reduce the time. It's like a flash of time. That's why known as flash method. And ultra high temperature method, here milk is heated in 2 stages. First 125 degree for few seconds, and then second stage is under pressure and then rapidly cooled. So tell me the 3 methods of pasteurization. Can you please share the 3 methods of pasteurization? Holder method, high temperature, short time. We have increased the temperature but decreased the time. Just a second. High temperature, short time. Okay, high temperature, short time. So first Holder method, then high temperature short time method, also known as flash method. Better to learn flash also. And ultra high temperature method. Tell me the temperature and time in each of them. That's it. As simple as that. Tell me temperature. Tell me time. Should be. Temperature here is 63. And 30 minute. 30 minute. Instead of 63, increase the temperature by 9 degrees. 72 kar do. So temperature increase hua. The time will reduce drastically. Instead of 30 minutes, it is only 15 seconds. And since it is only 15 seconds, it is known as flash of light, very fast. And here it is in 2 stages. The first stage is 25 degree under pressure, and second is under pressure, I mean. Okay, got it? So these are the 3 methods you have to learn. Please learn. Does pasteurization kill all the bacteria? Yes, all the bacteria get killed except spores. Pasteurization do not kill spores. Number 1, it is not sporicidal. And by Holder's method, Coxiella burnetii is not killed. By other methods, it is killed. So please learn. This is microbiology part I taught you. Okay, so this is regarding the pasteurization. The same thing is written in front of you. You can see the Holder's method, the high temperature short time method, flash method, ultra high temperature method. 63, 30 minutes, 72, 15 seconds, 125 for few seconds. That's it. Can we go? If you have small quantity milk, go with Holder. Large quantity milk, go with this method. and this is the under pressure. Okay, can we go ahead? This is how pasteurization is done at large scale. Can we go ahead? Say something. So how many tests of pasteurization are there? There are 3 tests of pasteurization available. What are the 3 tests? Phosphate, standard plate count, and coliform. These are the tests for pasteurization. Most commonly we use phosphate test. Most common. And after pasteurization, we can do methylene blue reduction test. What is methylene blue reduction test? What is methylene blue? Have you heard about this test? So methylene blue is a dye. Milk is white in color. Everyone knows. Imagine I'm having 3 different milk. Okay, from 3 different pasteurization units. So I want to see which pasteurization unit is best. Pasteurization unit A, B, C. So 3 different milk samples I'm having. And I'm the tester. I'm using which pasteurization unit and machine is best one. So what I will do, I will add equal quantity of methylene blue in all the 3 milk. Okay, so all the milk will convert blue. Milk is white in color, but if we are adding a dye, methylene blue, they all will become blue. They all will become blue. Now, if the milk contain bacteria, listen, milk contain coliform, a little bit of coliform. So coliform, the bacteria used to oxidize the methylene blue. And methylene blue convert into leucomethylene blue. Methylene blue, MB, convert in LMB. Leucomethylene blue, which is colorless. Methylene blue is blue in color, but leucomethylene blue is colorless. So if bacteria is present, after adding, the milk will become colorless again. You got my point? So more the time, the milk will be still blue color, the less is the bacteria. And less the time, immediately after adding the methylene blue, it become again white in color. Means maximum bacteria are present inside that. The pasteurization is not good. Say yes, you got it. You got the principle. This is methylene blue test. What is methylene blue test? You got it. So we are adding equal amount of methylene blue in all 3. So they all become blue, blue, blue. But this is remaining blue till end. This is becoming light blue. This is becoming maximum light blue or white in color. Because here maximum bacteria are present. And they convert the methylene blue to leucomethylene blue, which become colorless. Here less bacteria are present, minimum bacteria. So here methylene blue will remain as methylene blue only. It is not converting to colorless compound. So this pasteurization is best and this is worse. This is how we can test the post-pasteurization milk. It is an indirect method to detect the microorganism in the milk. The milk contains bacteria. How much? This test is carried out on the milk accepted for pasteurization. The blue color disappear from the milk when held at a temperature of 37. So blue color keep on disappearing. So milk will remain blue for the longest time is the best quality. Best quality का milk कौन सा है? Which is of longest time blue. The blue remains as blue only. It is not becoming colorless. How many of you got it? Methylene blue test. So Amit, one more. Beautiful girl called as heroine. Let me see. Yeah, beautiful girl called heroine. Yes, this one is also good. You can learn. Beautiful girls called heroine. Okay, better one. Can we go ahead? Okay, G. Let's move ahead. Okay. So these all are milk-borne diseases. Okay, you can see milk-borne diseases can occur. Anyways, let's come on the questions. Pasteurization by Holder method is heating the milk at what? Tell me the temperature, tell me the time. I'm asking the Holder method. Tell me the temperature, tell me the time in Holder, fast. Yes, so temperature is 63 to 66 for 30 minutes. You all are right. So correct answer is B. Okay. Phosphate test in milk is done to know what? The quality of pasteurization, the contamination of milk, the nutritive value or coliform count. Why we perform phosphatase test? I'm not asking methylene blue test. I'm asking phosphatase test. So it is used for quality of pasteurization. The next question, which of the following milk contain least amount of protein? Least amount of protein. Now apply your mnemonic, जो भी mnemonic apply करना है. Protein का mnemonic क्या है? So what is the mnemonic? I told you ना. Beautiful girls called heroine. है ना? भाई गोवा चलते हैं. Whatever you say. So this is the mnemonic for protein. So minimum is present in human milk. So what is the correct answer? Human milk. Yes. So if I change the word least to most, maximum, what is the answer in that case? In that case, answer will become buffalo. So minimum in human milk and maximum is in buffalo. Learn the mnemonic. So this is the mnemonic. Whatever you apply, but this is the mnemonic. Okay. Can we go ahead? Okay. Compared with cow's milk, mother's milk has more what? Mother's milk means human milk. Human milk have only one thing more. What is that? Only one thing more is present in human milk. So I told you every time the mnemonic is Bhai Goa chalte hain this, but for lactose the mnemonic will be HBGC. H will come in the front, है ना? For lactose. So correct answer is lactose, and you all are right. The correct answer is A. Okay, so compared to cow's milk, mother's milk have only one thing extra. So that is lactose. Can we go ahead? Milk is also done. Okay, so coming on the next topic, nuts. Nuts. Do you eat nuts? This is almond, है ना? Badam. This is cashew nut, kaju. This is walnut, that is akhroot. And this is groundnut, मूंगफली. है ना? Hindi version also I told you. So see, fats, they all have fats. है ना? Stored fats. How much 1 gram of fat give energy? I told you 9 kilocalories at the beginning of the session only. So 1 gram of protein, carbs and fat, how much they give? So carbs give 4 kilocalorie, protein also give 4 kilocalorie, but I told you fats give 9 kilocalories. Hai? That's why you have seen if someone is traveling and cannot carry much food with them, they carry dry fruits with them. Dry fruit is something that is carrying less space, but it will give you more energy. So it will give you 1 gram will give 9 kilocalories. Hai? The terrorists also carry this thing, dry fruits with them, because they can't carry much food with them. So if someone is traveling for a long journey and cannot carry much food, they carry the dry fruit, because dry fruit contain the fat, maximum fat. You can see maximum fat is present in walnut. Out of 100, 64% fat is present here. Maximum. It is a myth that people say cashew nut have. Means I was thinking before that कि cashew nut में सबसे ज़्यादा होता है fat. No, walnut में होता है. So walnut have maximum fat that you have to learn. That's it. Okay, can we go ahead? So these all are nuts. Coming on the egg. What is the next thing? The next thing is the egg. Egg. So this is one egg. You can see. Egg contain everything except two things, C and C. Egg don't have C and C. Egg don't have carbs. Egg have protein. It is having protein, fat, energy, but no carbs. It have other vitamins, but no vitamin C. No vitamin C. So egg don't have C and C. Please learn. Okay. 1 gram of protein. Acha, ye to theek hai. You don't learn this. You got it? So this is egg. One egg is nearly 60 gram. Nearly on an average, one egg. On an average weight, it's 60 gram. Normally, one egg. It contains 6 gram of protein, 6 gram of fat. Learn. Protein and fat, 6 gram. 6 gram of protein, 6 gram of fat. And total energy is 70 kilocalorie. Okay. You tell me 1 gram of protein give how much energy? 4. So 4 into 6, how much? And 1 gram of fat give how much energy? 9. So 9 into 6, how much? I'm just doing the calculation. Just don't do that. 9 5s are 40, 9 6 are 54. It should be almost 70. I just want to prove that. Almost 70. Not exactly 70, 80 will work. Say yes, this is how we calculate. Don't learn it, the calculation. Just learn. Just for your knowledge, I told you. This is how you have to correlate the things. So 6 gram protein, 6 gram fat, total 70 kilocalorie of energy. Okay. It is having little bit cholesterol also. 250 milligram. It is having iron also. It is having calcium also. But it don't have vitamin C. It don't have carbohydrate. The egg protein is a reference protein, the best quality. ये जो 6 gram है सिर्फ 6 gram. It is having only 6 gram of protein, but it is the best quality. 100% it is absorbed. NPU is 100. Whatever you eat, actually NPU is not 100. NPU is 96. But 96 is as close as 100, so we consider it as 100. So whatever you eat in the egg, the protein, 96% of it will be absorbed. For soya bean, it is only 40%. Whatever you eat, I told you, 100 gram of soya bean. If you remember, I told you, contain 43 gram protein. Have I told you? And here I am saying you 60 gram of egg contains 6 gram of protein. You tell me. Here 100 gram contain 43 and here 60 gram contain only 6. So quantity wise, of course, soya bean is best. You will say, ma'am, 43 is much better. But if you eat 100 gram of soya bean, only 50% of it which will be absorbed. And if you eat 60 gram of egg, 100% of which will be absorbed. So best quality is the reference protein is the egg protein. Here NPU is not 100, actually it's 96. But 96 is as close as 100, so we take it as 100. So this is the reference protein. You got it? Now you tell me the raw egg is good or boiled egg is good? Raw egg is good or boiled egg is good, and tell me the reason. Tell me the reason. Which one is good? Of course, boiled egg is much better. Nutritive value is more. Why? Because of boiling, there is a protein which is avidin. It is destroyed. And it is destroyed. Avidin inhibits the promotion of biotin, inhibits the absorption of biotin. So by boiling, we are destroying the avidin. Now biotin can be absorbed. So that's why boiling is superior to the raw egg. Boiled egg is much better. This is the reason. Okay, tell me the questions. Reference protein is present in which food? Is it milk, meat, egg, or pulses? They all contain protein. But reference protein is the best protein, the quality wise, where NPU is 100. Come on, people, respond fast. Now, so correct answer is egg. Anna, why? Because NPU is 96 or else 100%. Anna, nearly 100. So correct answer is C. You all are right. Egg is poor in what? Egg is deficient only in two things. Is it protein, carbs, and vitamin C, calcium and iron, or fats? Egg contain everything. Learn the composition of egg. You have to. 60-gram egg may how much protein, how much fat, how much energy, how much iron, how much calcium, how much cholesterol. Tell me everything. Protein is 6. Fat is also 6. Energy is 70 kilocalorie. Iron you have to learn 150 milligram. Calcium 30 and cholesterol 250. You have to learn everything. Anna, please learn that. Yes, CC is absent. You all are right. Correct answer is B and you all are right. Okay. NPO of egg. Is it 140, 96, 81 or 52? Fast. So actually it's 96. Anna. So if instead of 96, 100 is also there, I will go with that because they are not nearly equal now. But exact it is 96. So whatever you eat now, 96% of it which will be absorbed. Okay, Ji? Anna. Next is fish. Okay, let's come on the next food product, fish. Fish is the richest source of vitamin A and D, both. Vitamin A is maximum in fish, vitamin D is also maximum in fish. Okay, it is rich in protein, calcium, phosphate, fluorine, iron. I told you fluorine also present in sea products. Okay, it is poor in carbohydrates and iodine. Fish don't contain iodine, है and it is poor in carbohydrates and iodine. That is okay. So, but that is the thing. Fish is a source of all except. I'm asking except, so answer will be iodine. Okay. Next is banana. You can skip, not very important. Okay. Coming on the next important topic, vitamins. Can I start vitamins? Are you people there? Can we quickly complete the vitamins? Just a second. Give me a minute. I'm coming on that. Wait a while. Okay. So let's start vitamins. There are two groups of the vitamins, fat soluble vitamin, water soluble vitamin. How many vitamins are there? The fat soluble vitamin is A, D, E, K. Hana, A, D, E, K. And water soluble is vitamin C and B complex. Hana. So B complex is how many B complexes there? We have B1, B2, B3, but no B4, B5, B6, B7, but no B8. We have B9, but no B10, B11, and directly B12. Hana. So we have B1, B2, B3, no B4. Okay, no B4. B5, B6, B7, but no B8. Hana. We have B9, no B10, no B11, directly B12. So 1, 2, 3, 4, 5, 6, 7, 8. Am I right? 1, 2, 3, 4, 5, 6, 7, 8. 8 B complex. Anna. Apart from that, we have ADEK. Apart from that, we have C. So we have A, B, C, D, E, and K. Anna. In the B, we have how many B? We have 8 type of B. B1, 2, 3, 4, no 4. 5, 6, 7, no 8. Anna. 9, no 10, no 11, directly 12. So these are the total type of vitamins. Say yes. Okay, say yes. Can we go ahead? So these are the vitamins. The first thing you have to learn their names. And the second thing you have to learn their, this thing. What do you say? Their daily requirement. Yes, Aditi, I know. That's why I also get confused that seafood contain iodine. And here I am saying the fish is deficient of iodine. So I will confirm this tomorrow. Because both the things I have taken from the reference book PARC only. So both the things are contradictory. So one of them should be wrong. So seafood contain iodine, it is true. But in seafood, if I'm not including the fish, I'm including other things, crabs and all. This is the thing. But I will confirm you tomorrow, definitely. Okay. So can we go ahead? These all are vitamins. Okay, you can see. Now please learn their names. Vitamin A have 3 forms: retinol, retinol, retinoid, and total they are known as carotenoids. B1 is known as thiamine, B2 is known as riboflavin, B3 is known as niacin, B5 is known as pantothenic. You can see panto मतलब 5, pantothenic acid. है ना? B6 is known as pyridoxine. ठीक है? B7 is known as biotin. B9 is folic acid. We all know. B12 is cyanocobalamin. We all know, I guess. है ना? Cobalamin, hydroxycobalamin, methylcobalamin. So basically cobalamin is there. Vitamin C is ascorbic acid. Vitamin D is ergocholecalciferol. Vitamin E is tocopherols. And vitamin K is phylloquinone. These are quinones. So please learn their names. सबसे पहले तो if I say riboflavin, you don't have imagination what is riboflavin. It's vitamin B2. If I say thiamine, you don't have imagination. Thiamine is B1. So learn their names. पहली बात, all the vitamin. First, learn how many type of vitamins we have. Second, learn their names. Third, their deficiency. Vitamin A deficiency leads to xerophthalmia. B1 deficiency leads to beriberi, also known as Wernicke-Korsakoff psychosis, especially in alcoholics. Okay. B2 deficiency leads to ariboflavinosis. A matlab absent. Riboflavin is absent. Riboflavinosis. B3 leads to pellagra. Very important question. B5 leads to burning feet syndrome. B6 deficiency leads to anemia. है ना? B7 deficiency leads to dermatitis. B9 deficiency, folic acid leads to megaloblastic anemia, or B12 also leads to megaloblastic anemia. You may be knowing. Folic acid also leads to neural tube defects. I guess most of it you are knowing. Vitamin C deficiency known as scurvy. Vitamin D deficiency in children it's known as rickets. In adults it's known as osteomalacia. Vitamin E deficiency, hemolytic disease of the newborn. You know vitamin E is required for synthesis of vitamin K. Okay, and vitamin K also leads to hemorrhagic disease of the newborn. Vitamin K is required for certain coagulation factors, I mean, not vitamin E. How many of you got it? Got it, everyone? Huh? Please learn the name of the vitamins, their names and their deficiency. How many vitamins we have? Vitamin A, B, C, D, E, and K. How many type of B we have? B complex. So B1, 2, 3, 5, 6, 7, 9, and 12. Learn their names. सबके नाम बताओ, इन सबके नाम. Tell me the names of all of them and tell me the deficiencies of all of them. The next thing, learn their normal requirement, how much you should eat them daily. Anna, and why vitamins? What does vitamins provide to us? Vitamin provides nothing. They have zero protein, zero carbs, zero fat. They don't have any nutritive value, but these are required for vital function of the body. That's why known as vitamin. Vita matlab vital function. So they don't have nutritive value, by the way. So how much we should consume them? So don't learn for all, but vitamin A and vitamin D is important. So learn their normal requirement daily, how much you should eat them. If you want to learn for all, you cannot learn. I mean, you will forget, but A and D is important. Can I go ahead? So I will teach you only two in detail, A and D. The rest, this table is sufficient. Learn this table. Maximum questions will be from this table. Anna, learn the table for the vitamin, learn their normal name and learn their deficiency, learn their requirement. Make one table containing all this information. Anna, requirement is specially for A and D. Can I start A? Vitamin A, I told you they are available in three forms: retinol, retinol, retinoic acid. Anna, they all are known as retinoids together. Okay, what is the function? We all have eyes. See, in the eyes we have retina. In the retina we have rods and cones. Rods is for night vision and cones is for colored vision during the daytime. We all know in the retina there are two pigmented cells, rods and cones. Inside the rod there is a pigment known as rhodopsin, which is required for night vision, dark vision. We can see in the darkness also, and we can see in the light, of course. So the vitamin A is required for rhodopsin synthesis. If vitamin A is deficient, rhodopsin will not form, rod will not function, person cannot see in the night. So this is known as night blindness. What it is known as? The disease is known as xerophthalmia or night blindness. Person have problem in night vision, not in the day vision. Okay, normal requirement, I told you how much normal requirement. What is the source? It is maximum present in halibut liver oil. What is halibut? It's a fish, the name of a fish. Halibut is the name of a fish. Inside that liver, the vitamin A is present, followed by cod liver. Cod is also a fish. So halibut followed by cod liver oil. Please learn the sequence. Okay, but this is non-veg. In the veg, it is present in green leafy vegetables. Green leafy vegetables. Okay, deficiency leads to xerophthalmia. In the ophthal also you will read there are 5 stages in xerophthalmia. First stage is night blindness known as nyctalopia, then conjunctival xerosis, then Bitot spot, then corneal xerosis, and then keratomalacia. I will tell you all 5 one by one. First is night blindness. Person have difficulty in night vision. Person can't see in the night. Person have difficulty in the night vision. Nyctalopia, night blindness. During the daytime the person can see, but during night person cannot see. This is the first symptom, earliest symptom. Usually the child have. Okay, so mother will come to you, my child cannot see during evening or in the night. So night blindness, you can see it's like this. Night blindness, person can't see during the night time. Okay, second is not Bitot spot, conjunctival xerosis. This is earliest sign. So Bitot spot is a dull, dry, wrinkled appearance, smoky appearance. Can you see this is conjunctival? See the conjunctiva. It is xerosis. It is dry, dull looking conjunctiva. So this is earliest symptom. The third is the Bitot spot. What is the third one? Bitot spot. You can see Bitot spot is a triangular white foamy spot. This is Bitot spot. Okay, the fourth is the corneal xerosis. The cornea also become dull and dry. And finally, cornea mein ulcer ho jayega. And finally, the complete eye convert into a pus-filled bag. Eye disappear and a pus-filled bag, liquefied. It is medical emergency known as keratomalacia. So tell me, what are the 5 or 6 stages? What is the earliest symptom? What is the earliest sign? Both are PYQs. Xerophthalmia, vitamin A deficiency. Earliest symptom is night blindness. Earliest sign is conjunctival xerosis. You know the difference between symptom and sign? Symptom, what the patient is saying to you. Sign, what you see in the patient. So night blindness is the earliest symptom. Conjunctival xerosis is the earliest sign. After that, Bitot spot, corneal xerosis, and keratomalacia. Say yes. Hana? This is complete regarding the xerophthalmia. Okay. This is complete thing regarding the xerophthalmia. Okay. Now coming on the prophylaxis. To prevent it, we give vitamin A. Vitamin A vaccine. You can say vaccine or prophylaxis of vitamin A. It is oral. It is not injectable. So this is coming in the form of the syrup. And a spoon is provided along with that. Ghar ka spoon nahi lena hai. The spoon is provided with that. The capacity of this spoon is 2 ml. It's a PYQ. The capacity. If you fill it completely up to the brim, 2 ml of medicine, 2 ml of vitamin A is inside that. 1 ml of vitamin A contain 1 lakh international unit. 1 ml contain 1 lakh. So 2 ml contain 2 lakh. Got it? Got it. So for prophylaxis to a child, how many doses has to be given? Total 17 doses under National Immunization Schedule. Anna, I will teach you National Immunization Schedule also tomorrow. National Immunization Schedule, NIS, we give total 17 doses. How many doses? The first dose is given at 9 months along with MMR. It is 1 lakh. 1 lakh. Okay, not 17 doses. I'm sorry. Total 17 lakh international unit we give. Let me tell you. After 9 months, the second dose is given every 6 months up to 5 years. So we will give at 18, then 24, then 30, then 36, then 42, then 48, then 54, then 60. Every time 2, 2, 2, 2, 2. Let me write it. So first at 9 month, then 18 month. Up 6, 6, 6 add karte jao. 18 में 6 add किया तो 24, then 30, 24 month, 30 month, 36 month, 42 month, 48 month, है ना? 48, 54 month, and 60 month. 60 month is equal to 5 year. है ना? So I'm adding 6, 6, 6, 6, 6, 6, 6 up to 5 years. So here the first dose is 1 lakh. Rest all doses are 2 lakh, 2 lakh, 2 lakh. Count total. So 2, 4, 6, 8, 10, 12, 14, 16 plus 1, 17. Total 17 lakh unit we give. How many of you got it? This is the National Immunization Schedule. You get question on 2 things here. In National Immunization Schedule, the vitamin A prophylaxis, the first dose is given when? It's at 9 months along with MMR, and it is 1 lakh. Rest all the doses are 2 lakh, 2 lakh, 2 lakh, 2 lakh, 2 lakh, 2 lakh. Every 6 months till 5 years, total 17 lakh is given. This is the complete thing. This is prophylaxis. How many of you got it? Say something, please. Say, people, say, respond. This is the prophylaxis. Hannah, it is given with the spoon. Hannah. So at 9 months, we fill the spoon, half spoon. Half spoon. Hannah, spoon is of 2 ml. And here, every time, we give the complete 1 spoon. 1 spoon. We fill it completely and give it to the child like this. You can see, we are giving it to the child. So if at 9 months, we will give half spoon and later on, we give the complete spoon. That's it. So this is the complete 17 lakhs. We are done with vitamin A prophylaxis. Read the question. Tell me the answer fast. First clinical sign. I'm asking sign. First clinical sign of vitamin A deficiency. I'm asking the sign. I'm waiting for your response. I'm waiting for your answer. Can you please answer? Meanwhile, I can drink water. Thank you for allowing the time. What's the correct answer? Some people are doing the mistake. Yes, the correct answer here is B, na? It's conjunctival xerosis. Why you are saying night blindness? I'm asking sign. If instead of sign I ask the symptom, the correct answer is A. But currently correct answer is B. It's not C. By mistake I have marked C. The correct answer is B. Got it? Can we go ahead? But if I change the question from sign to symptom, then answer will become A. Devbatra, Amit, Megha, answer is not A. Hana, you got it? Currently answer is B. But instead of sign, if I say the symptom, answer will become A. So there is a difference between symptom and sign. No, don't do the silly mistake. If you want to do the mistake, do it here. Don't do it in the exam. Okay, better to do the mistakes here. Anyways, so let's go to the next question. Tell me the dose of vitamin A prophylaxis we give 6 to 11 month. 6 to 11 month, we give the first dose at 9 month. So at 9 month, what is the dose we give? 2 lakh, 30,000, 60,000 or 1 lakh. The 4 options are in front of you. How much we give? At 9 month, the first dose is always 1 lakh. Anna? And after that, if I change anything, all other doses, it will be of 2 lakh. So total 8 doses of 2 lakh, 8 2s are 16 plus 1 dose 17. Anna? Total 9 times we give prophylaxis. So let's come on vitamin D. Vitamin A is done. Let's come on vitamin D finally. Okay, vitamins will be done then. So let's come on vitamin D. There are 2 forms of vitamin D, D2 and D3. D2 is cholesterol, D3 is cholecalciferol. Vitamin D, vitamin D is synthesized in the skin. We know in sunlight, in presence of sunlight. Okay, vitamin D is required for mineralization, that is calcification of the bones. The only one function. Okay, source, it is also present in the same, like vitamin A, in the fish liver, halibut followed by cod. So vitamin A and D, the sources are same. Halibut liver oil followed by cod liver oil. So fish liver oil is the richest source for vitamin A and D both. Deficiency in children, it's known as rickets. In adults, it's known as osteomalacia. In children, it's known as rickets. In adults, it's known as osteomalacia. Say something. No. Okay, in children, it's rickets. In adults, it's osteomalacia. So coming on rickets. पहले हम rickets देखेंगे, है ना? So rickets में, in the rickets, the first thing happen in the rickets is craniotabes. What do you craniotabes? Both, you can see it is the earliest manifestation. What was the earliest symptom and sign in vitamin A? Symptom was night blindness and the sign was corneal xerosis. What is the earliest symptom or sign here? You can say it is craniotabes. What is craniotabes? Just a second. You can see the skull become like ping pong ball. Yes, ping pong ball. I use the word ping pong ball. Hana, if you compress, you can compress the skull. If you leave it, it will be released again. Have you seen a ball, ping pong ball? You compress, it is released. It compress, it is released due to soft membranous bones in the skull. In the skull, the bones become soft and membranous. So it is looking like a ping pong ball. It is known as softening of the skull. Craniotabes, you can see here. Craniotabes, we can see. The earliest manifestation. Learn the earliest manifestation in both of them. The vitamin A and vitamin D. Apart from that, there is rickettsial rosary. So here is the sternum. And these are the ribs. Let me draw the ribs. These are the ribs I am drawing. Both the sides. You can see. These all are the ribs. At the junction of the sternum and the ribs, you can see there is beading. Beading and moti jaisa. The junction of the sternum and the ribs get nodularity. It is looking like a beading. It is known as rickettsial rosary. Can you see the beading? Appreciate the beading. The costochondral junctions look like beads. It is known as rickettsial rosary. Say yes. So this is known as rickettsial rosary. Okay. The next, the chest, the sternum is protruded out. The sternum is protruded out. It is looking like a pigeon chest. It is known as pigeon chest. The next, at the junction of the diaphragm, you can see a groove. Can you see the groove here at the junction of the diaphragm? Where diaphragm is there. At the insertion of the diaphragm, it is known as Harrison's groove. So learn the pigeon chest, learn rosary, learn craniotabes, and learn Harrison groove. The next is the pot belly. The complete abdominal muscles, they are very weak, so they get protuberant. They get very flabby due to hypotonia, and there is abdominal protuberant. It is known as pot belly. Can you see the pot belly? Typical pot belly. Appreciate the pot belly. Apart from that, scoliosis, kyphosis, and scoliosis is there. You know what is lordosis, what is kyphosis, what is scoliosis? You can see the concavity is lordosis. The convexity is kyphosis, and you can see the S-like architecture is scoliosis. Okay, apart from that, the genu valgum, the knee lock can be there. Knee lock. So please learn them one by one. What we have learned, the earliest is the craniotabes. After that, I told you rickettsial rosary. After that, I taught you the pigeon chest. Anna. The next, I taught you the pot's belly. Okay, I taught you the Harrison's groove. Harrison's grooving is there. Okay, so learn all these catchy words. You can get questions on that. Can we go ahead? Vitamin D is maximum in which food? Milk, fish fat, egg, or cod liver oil? What is the correct answer, please? Fast. What is the correct answer? Please, fast. I'm asking. Yes. Yes, the correct answer is cod liver. I was better answer was if option contain halibut. So halibut liver oil is not given. We will go with cod liver oil. Okay. So that's it. So let's go on the last topic of this chapter. I guess food adulterants. What is the last topic I want to cover here? Food adulterants. हिंदी में कहूँ तो adulterant मतलब मिलावट, है ना? मिलावट करते हैं ना खाने में, है ना? For cost cutting, it is done, right? For example, खेसरी दाल. uh, there is a dal known as arhar dal. We all eat that dal, the yellow dal, the arhar dal. It is a normal dal, है ना? It is little bit costly, है ना? But khesri dal looks like arhar dal only, but it's not good. It's not good, but it's very cheap, है ना? So some people, what they do, they mix the khesri dal with arhar dal and sell it just for cost cutting. They do so, है ना? This is known as adulteration. So khesri dal contain a toxin inside that. The name of the toxin is BOA. BOAA. I will tell you the full form also. है ना? Beta oxyl amino acid, right? BOA. It is a toxin, है ना? And it produces paralysis in human. So it is known as letharism. So because of little bit cost cutting, the person is having paralysis. It's a crime. Okay, this is food adulteration. How many of you got it? What is the adulteration? So we have to study 5 adulteration. They all are in front of you. So please learn. Ultimately, you have to learn this table, but I will show you the figures so that you have a better understanding. So first is letharism. है ना? Letharism. So there is a dal which is known as arhar dal. We mix means some people mix arhar dal with khesri dal. Khesri dal, the scientific name of khesri dal is Lithyrus sativus. It contains a toxin BOA, BOA, है ना? Beta oxyl aminoalanine. Beta oxyl aminoalanine. Okay. It can cross the blood-brain barrier if constantly given and produce neuroparalysis, spastic paralysis. You can see the person can become parastalytic. See, this is arhar dal, this is kesri dal. Both of them almost look same. So if someone is mixing this with you cannot identify that this is arhar dal or kesri dal. Arhar dal is normal dal. Kesri dal contains the toxin and it is very cheap. So this is done. This is known as one of the food adulteration, and person have neurolitharism. The person will have paralysis if constantly consuming the kesri dal for 2 months, not once. It is constantly consumption for 2 months. It is not directly paralysis will occur. There are 5 stages. Number 1, latent stage, then no stick, 1 stick, 2 stick, and crawler. You can see no stick. This is 1 stick. The patient can walk with 1 stick. The patient required 2 sticks to walk, and finally the patient become a crawler, not walking at all. So these are the stages, and finally the person have complete paralysis. What to do? If I want to eat arhar dal and I want to become sure I'm not eating the toxin, so vitamin C prophylaxis should be given, along with the dal, or banning of the crop. Banning is already there. Someone is doing the field. Someone is doing the kya kehte hain, agriculture of the khesri dal. It's a crime. It's a crime. But people still do that, and removal of the toxin. Sometimes by boiling it's possible. So before eating the dal, first boil it, remove the water, it's water soluble toxin, and then cook the dal if you want to become sure. So this is all about litharism. Say yes. Got it? So what is the first I told you? Name the dal, arhar dal. What we mix in that? Arhar dal, we mix khesri dal. Khesri dal is Lithyrus sativus, and it contains a toxin. The name of the toxin is beta oxyl aminoalanine, BOA. It's a toxin. It goes in the brain. It crosses BBB, grows in the brain, and produces spastic paralysis there by damaging the brain, by damaging the spinal cord. Spastic paralysis. Person have latent stage, 1 stick, 2 stick, and finally a crawler. And if it is consumed mainly for constantly 2 months, and it's a crime to grow the kesari dal. So these all are important points in that. Okay. So by boiling, we can remove that. By boiling, the toxin becomes soluble, and you remove the water and then cook the dal. So this is arhar dal. So first we are done with litharism. The second, there is a oil. Have you seen, what do you say, this oil? Kya kehte hain usko? Which oil you say? Let me see the word I'm missing. Mustard oil. We eat mustard oil now, especially in the pickles and all. Mustard oil is very commonly used in India. Mustard oil is yellow in color. Same like that, there is one more oil looking like mustard oil. It is Argemon mexicana oil. Argemon mexicana. So it is very cheap. Mustard oil is costly. So for cost cutting, people mix it. Argemon mexicana oil with the mustard oil, and it contains a toxin. The name of the toxin is known as sanguirin. The name of the toxin is sanguirin, and it produces epidemic dropsy, a disease. So learn the adulterant, learn the toxin, what does it contain, and learn the disease it is caused by that toxin. Learn in this sequence. So here you can see mustard oil is mixed with argemone oil because both of them look similar. And this argemone oil contains a toxin sanguine. It interferes with pyruvic acid oxidation in human body and produces a disease that is epidemic dropsy, in which person have sudden swelling of the legs. Sudden swelling of the legs is there, diarrhea, dyspnea, glaucoma, multiple cardiac failure, shock, and ultimately death. This is epidemic dropsy. You can see epidemic dropsy. Okay, epidemic dropsy is there. The next is the endemic toxic, है ना? So here there are seeds, है ना? We eat many seeds, na? The sunflower seeds and many seeds are good for health. So crotalaria seeds looks like other seeds only. So it is used as a contaminant or adulterant. It contains a toxin. The name of the toxin is pyrazidin alkaloid, and it produces endemic ascites. It produces endemic ascites. The next is Aspergillus flavus. It's a fungus. It can contaminate the food. If someone is eating the food which is contaminated with this fungus, aflatoxin is produced, which is a toxin, and it produces aflatoxicosis. And last is Claviceps fusiferum. It produces a toxin known as clavine alkaloid, and it produces ergotism. So please learn this table. I want you to learn the name of the adulterant. I want you, what does it contain? It contains a toxin, name of toxin, and that toxin produces a particular disease in human body. So learn the 5 adulterants. Okay, say yes. You get questions on that. So tell me the answer. Endemic ascites is caused by. I'm asking endemic ascites. Name the toxin which causes endemic ascites. Yes. So correct answer is pyrazidin toxin. है ना? You have to learn this table. Epidemic dropsy is different. Endemic ascites is different. If I change the question from endemic ascites to epidemic dropsy, answer will become sanguine. Anna, in this way, if I can change the question, the answer will change. The next question is that only. Epidemic dropsy caused by sanguine. Okay, BOA is a toxin responsible for what? BOA, beta oxyl aminoalanine. It is responsible for epidemic dropsy, neurolitharism, endemic ascites, or fluorosis. Of course, it is neurolitharism. The person become paralytic, spastic paralytic. The next question is in front of you. There is a 42-year-old woman from a dry state who ingested rye for a long time. Complaints of weakness of both the limbs, nausea, fatigue. And now, over due course of time, she is completely unable to walk. So what is the typical scenario? Is it Litharis sativus, ammonia, Argemone mexicana poisoning, or ergot alkaloid? So they are talking, the female is consuming, although the rye, better was the question, instead of the rye, she was having a consumption of the rye. Instead of that, if they give the arhar dalna, it was a better question. They are talking about the Litharis sativus only. Okay. So instead of that, if they give arhar dal or some pulses, it was a better question. So correct answer is A only. Can we go to the next question? This was food adulteration. Now let me tell you food fortification. What is food fortification? We are adding something additional to the food to improve its quality, to maintain or improve the quality of the diet. For example, we fortify the salt with iodine. It is not an adulteration. It is fortification. Salt has its nutritional value, but I'm increasing its nutritional value by adding iodine also, by adding iron also. Double fortification, twin fortification we do. So we are adding something additional in the food to increase its quality. So that is the thing. Got my point? It is a primary level of prevention. Okay? So criteria to be food to be fortified. Take the example of salt. We fortify salt with iodine. We all know that. So whatever vehicle you are using, it should be regularly consumed. All the rich, all the poor, all the religion, Hindu, Muslim, everyone should consume that thing. So salt is something everyone is consuming. It is not the thing some people are consuming, some are not consuming. And the amount you should add at 30 ppm only. Don't add too much. Pata chala deficiency nahi to excess ho gayi. So amount of fortification does not cause the deficiency or toxicity. It should be neutral, like average. Okay. And by adding iodine in the salt, it should not change its color or taste. No color, no change in the taste, no change in odor. And it should be still affordable. Iodized salt is little bit costlier than as compared to normal salt, which is non-iodized, but it is not very unaffordable. कि इसमें iodine है तो अब बहुत costly हो गया, ऐसा नहीं होना चाहिए. Little bit of cost increase should be there, but it should be still affordable. So these are the criteria for fortification. Example, we know iodization of salt. Adding vitamin A and vitamin D in vanaspati, dalda, I told you. Fluorination of water. In water where fluorine is very deficient, and if excess of fluorine is there, we remove it by Nalgonda. Fluorine is a double-edged sword. Okay, adding calcium to the fruit juices, adding folic acid to the flour and atta. These are the examples of the food fortification. How many of you got it? How many of you got it? Can we go ahead? The last thing is the food regulation. You must see food regulation. So whatever I'm purchasing some food from the market, in the market I'm going to a mall, to some market, and I want to purchase any food, a packed food, so how should I rely the food is of good quality? Is there any regulatory committee which gives it seal if the food is of good quality? So there are many food regulations are there. The most important is Codex Alimentarius Commission. It is intergovernmental global body, है ना, of FAO and WHO. You have to look for this Codex. If Codex is giving, its seal on that, it is written here. You can see the WHO, है ना, means they have already checked the quality of this food. So you can be assured. In the India, it's FASI. Have you seen FASI written on most of the food in India? It's Food Safety Standard Authority of India, FSSAI. Food Safety Standard Authority of India. Along with that, AGMARK is there, Bureau of Indian Standards. These all are voluntary. These are, someone, just suppose I'm opening a factory today, pasta factory, I'm manufacturing pasta. Now it's my choice. If I call the FASI people, this committee, I will give them their fees, money, whatever, and they will check the quality of my food. After checking, they will give their seal. So people will have reliability on my food that it is FASI approved. So I can increase the authenticity of my food by doing so. It is voluntary. Some can do, some cannot do. It's voluntary. So these all are the food regulatory committees. That's all. So here, midday meal program, I'm not covering here. You want me to cover it here? Let me see. Okay, so midday meal program, the last program I'm covering. The remaining programs I will cover in National Health Program. What is midday meal program? The last thing we are covering in nutrition. Midday meal program. Midday meal program. What is MDM, midday meal? So in the school, in the government school, not in private school, in the government school, food is provided to the children free of cost. That is midday meal program. What do you think? Why we are providing the food to the children in the school? Why we are providing food to the children in the school? To improve their nutrition. These all are poor children. They cannot afford the food. Why we are providing? Why government is providing free food to the school children in government school? Why? To increase their attendance. The main thing is attendance. The main thing is attendance of the children. So what we have seen now, students like children take enrollment in the government school, but they don't come regularly. So to attract them, that we will provide you daily delicious food also. So for that, the children will come. The parents will also send you will have food there. So we not to study, to just increase the attendance. So this is the main purpose. Not admission, not it's the attendance. Okay, admission to koi bhi le lega, lekin attendance increase karne ke liye. Okay. So what is the criteria? Only supplement, not a substitute. The parents should not think that the food should be provided in the school and they should not give the tiffin box or they should not give the meal at home to the children. It is a supplement, not a substitute of the home food. Home food should be continued as it is. It's a supplement. Additionally, the government is giving. The number one. Number two, it should total calorie requirement of this child is whatever it is, 1/3 of the calorie and half of the protein should be given in the school out of the total 24 hour. So 1/3 of the calories and half of the protein should be provided in that, regarding to the age of that child. It should be simple and cheap food. It is not keep pasta, noodles, and some hi-fi food we are giving. Simple dal, roti, chawal, sabji, we will give that. Simple, cheap cooking. And it should be locally available food. Okay, and changing menu should be there. It should not be monotonous. So there is a weekly changing menu, Monday, Tuesday, Wednesday, like that. Okay, main object is to attract more children for admission and retain them for literacy, attendance. So we want to increase the literacy rate. That's why we are providing free food to the children. Okay, the health program is run by Ministry of Education, not by Ministry of Nutrition. This midday meal program, who is the in charge? The Ministry of Education. Okay, it is still 8th class. So from 1st standard to 8th standard. Not beyond that. After that, 9th, 10th, 11th, 12th standard students will not get the food. They want to study, they will come, otherwise they will not come. Up to 8th standard, this program runs. So it is like that. You can see, 1/3 of the calorie and half of the protein is provided here. It's a supplement. It's not substitute. It's a supplement. It is cheap. It is simple. It is changing menu. It is run by the Ministry of Education. Okay, to increase the attendance and admission. Got it? Say yes or no. Say something. So how much energy we provide? है ना. In the primary यानी up to 5th standard, it is 450 kilocalorie per day, and 6th and 7th and 8th standard upper primary it's 700. The protein here is 12, here is 20 per day, इतना gram per day, है ना. So this is how we provide. Minimum 250 days per year. बचे हुए तो vacation and Sundays are there ना. So minimum it should run for 250 days in a year. In a year there are 365 days, है ना. There are summer vacation, winter vacation, Sundays, national holidays. So minimum it should be for 250 days in a year. Got my point? Say yes, है ना. The recommendations are reduce the cereal intake from 100 gram to 90 gram, and from 150 to 125. They want to reduce the cereal intake, and addition of milk and milk products should also be there. Eggs should also be provided. Bananas should also be provided, है ना. And oil should be only 5 to 10 grams. It should be used, है ना. And mixture of three oils should be used, either palm oil, coconut oil, and ghee, or sunflower, mustard, and soybean oil. And salt should be double fortified salt. So in the salt, iron and iodine is also provided. So these are the recommendations. You have a look on that. That's it. So read the question, tell me the answer. Midday meal program contains protein and calorie of what proportion? Half protein, half calorie, half protein, one-third calorie, one-third protein, one-third calorie, or two-third calorie, one-third protein. I told you the recommendations. I told you the guidelines, I mean. Midday meal program. I'm asking. Yes, Elizabeth, you are right. Others are sleeping, I guess. Many people are awakened. So the correct answer is half of the protein and one-third of the calorie. Out of the total requirement of that child, it should be provided in the midday meal. So that's it. Hana, ICDS program I'm not covering here. I will cover in the National Health programs. So that's all about it. We are done with unit 2 also. Congratulations. So we will start the third unit now. Are you people there? Still alive? Still alive? Say something. Huh? Are you people still there? So I'm thinking instead of starting the big chapter, let me start the screening of the disease. It's a small unit, we can finish it in an hour or so. Can I start? Huh? So because otherwise I will start the obstetrics and pediatrics. I have to leave it in between. So tomorrow fresh in the morning, I will start that. Currently, I'm starting with this thing, screening of the disease. So let's start with screening of disease. Okay, so today we will be able to complete 3 out of 4. Tomorrow we will increase the speed a little bit. We will try to cover 5 tomorrow. Okay. 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 So can we start? 1 more hour. Okay. Can we take a small coffee break if you allow? After that, we can continue for 1 hour. We can. So currently, it's 4:45 now. Let's take 15-minute break. Let's start again at 5 to 6, 1 hour or 40 minutes, 5 to 5:45. Okay, ji, है ना? So I'm not ending the session. I'm just switching off the camera and the mic. I will be back at 15 minutes. है ना? Have a coffee, tea, you also, so that we can continue for 1 more hour. Okay, 5 sharp. Am I back? Visible, audible? Hi, people there. Can you respond in the chat box? Let me open the chat. Can we continue with the next unit? Screening of disease? Yes. So can we continue? Okay, thank you. Thank you for responding. Thank you. So let's start with screening of disease, the next unit. It's a small unit. You can understand. You usually get numerical from that. Okay. So let me tell you what do you mean by screening. Okay. We have a community of people. Imagine this is our complete population. Hana, in the population, two type of people are there. The diseased one and the healthy one. The diseased one are the one who know they have disease. Hana? They will run to the doctor and they will seek for the treatment. They know they have something wrong in their body, and there is another population who think that it is healthy, the one who don't have any symptom. Just suppose currently I don't have any symptoms, so I think I'm healthy, right? So maybe here the diseased one or the diseased one, there is no further classification in that. But the healthy one, there are two type of healthy one. The one who are real healthy, they are really healthy, they don't have any disease inside them. But one who are apparently healthy, I'm using the word apparently. What do you mean by apparently healthy? They think they are healthy because they don't have any symptom in them, but actually they are not healthy. The disease already started inside them, but still in subclinical, I mean inapparent. There is asymptomatic. These people are asymptomatic, they don't have any symptom, they are in subclinical stage. Disease is very small, it started but not produced symptom yet. You got my point? You got my point? So these people who are already diseased, they will run to the doctor, they will run to the physician, that doctor, I'm having something wrong in my body, please check and give me the treatment. So here we apply the diagnostic test on them and we give treatment to them directly. But here what happened to these healthy people? These apparently healthy people, they think they are healthy, they don't have any symptom inside their body, so they will not come to us. And how to separate it from real healthy? So here we apply screening test on all of them. Screening test is a test which is applied on healthy people to separate the apparently healthy from the real healthy. Hana? So screening test is negative in them and positive in them. Screening test is a test which detect the disease even in minute quantity. The disease is very small, very minute in human body. The screening test will detect it. Hana? So here we will give them what is the purpose? Why we are performing? You must ask me, ma'am. They will present someday, na? Someday they will have the symptom. They will come to us. Why we are taking the trouble to go to them? Let them come. Let's wait. The disease will progress. They will have certain symptoms and signs. At that time, they will be diseased and they will run to us. They will run to the doctor. At that time, we will treat them. Now, there are certain diseases in which early treatment is required, especially in the cancers. I know. If we give them early treatment, now the prognosis is something else. As compared, we are giving the treatment at usual diagnosis. So this is the usual diagnosis. Just suppose there is breast cancer. The lady is coming to us at stage 2, stage 3. But what if we can detect at stage 1 only? Anna, we can have better prognosis if we start the treatment early. Before the patient presents, we give the treatment. Before the patient have the symptom, we give the treatment. So prognosis, to make the prognosis better, this is the ultimate purpose of screening test. How many of you got it? What is screening test? I told you what is screening test. So screening test is a test which is performed on healthy people to differentiate the apparently healthy from the real healthy. What is apparently healthy? Apparently healthy are the individual who think they are healthy, but actually they are not healthy. They have certain disease inside their body which is already started. What is the purpose of screening test? To give early diagnosis and early treatment so that we can give a better prognosis. How many of you got it? This is the introduction. Respond. So this is screening test. Screening test is active search. It is not passive. People are not coming to us. We are going to people. It is the active. That is the meaning of the active. Active, passive. It is not passive. We are going to the people. We are doing active search of the disease among the apparently healthy people. Now you got the meaning of the apparently healthy. They think they are healthy, but they are not healthy in the community. Hai na? So by means of rapid applied test. Okay. So that we can give early management to them in the hope we can reduce the mortality and morbidity. Hana, especially in cancers, if we can detect it at early stage, we will give them early treatment and we can reduce the morbidity and mortality. Hana, so that is the we want to improve the prognosis. That is the meaning of the screening test. You should know what is screening test and why to perform that. Hana, we are not performing screening test on diseased individual. We are performing screening test on apparently healthy individual. They think they are healthy, but they are not healthy. Hana, so in the iceberg, they represent the submerged portion. I want to diagnose them. They don't have. I already explained you the iceberg phenomenon in the morning. How many of you were present in the morning? I told you the iceberg. This is the tip which is very small, and this is the greater submerged portion. The tip is very small. It represents the cinematic case, and the submerged portion represent the undiagnosed case, asymptomatic cases, है ना? So I am interested in the submerged portion now, है ना? The tip will come to the doctor. We don't have to go to them. This is actively they come, but here passively we go to them, the submerged portion, and search them with the help of the screening test. Got it? Got it? Can we go ahead? This is the aim of the screening test. So let's go ahead. Okay. Sanjay Kumar, I already explained. Na? In the morning, you can watch the recording. In short, I'm explaining you here. So when we take an iceberg, you can see in the iceberg, the tip is very small. Hai a very small tip is visible. You can see this portion. I'm talking about this portion. A very small portion is visible. This is known as tip of iceberg. And maximum portion is submerged. It's always there in all iceberg in water bodies. This is the submerged portion. The submerged portion is vast. So tip is very small. I mean to say, you can write small, and the submerged portion is very vast. What we compare the diseases in the community, any disease in the community, with the iceberg. I mean to say, when we compare any disease, the symptomatic cases, the diagnosed cases, the person who have the clinical features, who have the symptoms, that represent the tip. They are coming to the physician. We don't go to them. They have symptoms. They will come, doctor, I'm having something wrong in my body. So we will do the diagnosis. We will do the treatment. So here we apply diagnostic test, not screening test. But the submerged portion is the people who have the disease, but they don't know they have the disease because they are asymptomatic. They don't have currently symptom. They don't have clinical features. They are latent cases. They are carriers. So here they don't come to us. We go to them and we apply screening test on them. And we cannot treat them directly. After screening test, again, we have to confirm with diagnostic test, and then we give the treatment. This is the complete process. You got it, Sanjay Kumar? So here I am interested in the submerged portion. The aim is to separate the apparently healthy individual from the real healthy. I want to separate them. So that objective, I can give them early treatment. If I give them early treatment, the morbidity and the mortality I can reduce. Okay. So this is the complete tree. So here all healthy people are there. I'm applying screening test. Screening test can be positive, can be negative. For example, if it is negative, so you do periodic screening every year, every 2 years. And if it is positive, confirm it with diagnostic test. If diagnostic test is also positive, give the treatment. If diagnostic test is negative, don't give the treatment, do periodic screening. So based on screening test, don't give the treatment. Got my point? Screening test is not used the basis of the treatment. If screening test is positive, you cannot give treatment directly. First confirm with diagnostic test. If it is also positive, then give the treatment. Okay, it is not a basis of treatment. Please understand. So screening test is applied on asymptomatic individual and diagnostic test is applied on symptomatic individual. I'm interested in screening test. How many of you got it? So tell me the differences between screening test and diagnostic test. Screening test is applied on apparently healthy individual. These are asymptomatic. They think they are healthy, but they are not healthy. And diagnostic test is applied on already cases. They have the sign and symptoms. This is applied in big population, the complete healthy group. And this is applied to the individual. One individual will come to us, doctor, I'm having some disease. Okay, here, this one is cheaper because I have to apply on the complete country. No, in the complete India or complete geographical area, I have to apply this test on everyone because everyone who is healthy, who thinks he is healthy. So I don't know whether he is real healthy or apparently healthy. So it should be cheap so that I can apply it in millions. And it should not be costly. It should be cheap. It should be rapid. In comparison, diagnostic, it can be expensive because we have to apply it on one individual. And here the costing of the individual, patient will come to us, doctor, do some investigation and diagnose what is wrong in me. So payment is done by the patient. Here payment is done by the government. Screening test, we are going to the people and applying it. People will not pay for that. It should be cheap. It should be rapid. This one time consuming bhi chalega. This one is relatively less accurate. This is more accurate. This is the basis of treatment. This is not the basis of treatment. Okay, this is done by epidemiologist and this is done by the physician. I already told you. Can we go ahead? Say something. So please tell me the answer of this question. Screening test has all of the following features except which is not a feature of screening test. Can you please tell me? Done on apparently healthy individual. It is less accurate. The results are arbitrary and final. It can be used as a basis of treatment. Which of the following is wrong for screening test? Tell me the answer. I'm waiting. What is the correct answer here? Which of the following is not a correct answer for screening test? I told you screening test never used as a basis of treatment. The results are arbitrary and final. They are arbitrary. They are arbitrary and final. But it is not used as a basis of treatment. No, you have to confirm it with diagnostic test, as I told you. What are the examples of the screening test? Why don't we perform screening test for all the disease? How many diseases we have? We have millions of diseases in human body. We cannot perform screening tests for all of them. Come on, है ना? It will be very costly, है ना? So we will perform only in which we actually change the prognosis by giving early treatment. There are two types of diseases. The one diseases in which if early diagnosis is done and you treat them before the patient presents, the prognosis is better. Or there are certain diseases, whether you treat them early or whether you treat them at the same time when the patient is presenting, the prognosis is good. So screening test is useful in the first case, where you can change the prognosis, especially in cancers. So we apply screening test especially for cancers. For cervix cancer, we apply pap smear. For breast cancer, we have two tests. है ना? Number one, breast self-examination. Number two, mammography. For oral cancers, है ना? Biannual oral examination. For HIV, ELISA is there. For diabetes, urine test is there. है ना? Fetal abnormalities, alpha fetoprotein is there. For prostate cancer, PSA is there. Yeah, digital rectal examination. And for colorectal cancer, the feces blood, occult blood can be the test. So these are the screening tests for corresponding cancers. So tell me, screening test is not useful for which cancer? I have enumerated the cancers for which screening test is useful. For colon cancer, we have a screening test. Yes, occult blood test in the stool. For breast cancer, yes, breast self-examination or mammography. Prostate, yes, we have PSA and digital rectal examination. For testicular carcinoma, we don't have any screening test. Okay, we don't have any screening test for testicular carcinoma. So say, yes, correct answer is D. Can we go ahead here to learn the examples also? I mean, Anna, learn these examples for which the screening test is available. Okay, can we go ahead? You have to understand the natural history of the disease if you want to understand the screening test. Everyone on the screen, it's difficult. I will try my best. Listen, but I will not repeat. Please understand. Imagine I'm a human body. Inside any human body, the disease is onset. The disease has started. Now, there is no test in the world that can detect the disease at the point it started. Disease has to grow a little bit, at least few centimeter. Then only you can detect it, whatever is the disease. At least some biochemical changes that should be done. Then only you can detect it. Otherwise, you cannot detect it. So this is the point of onset. The disease already started inside human body. And this is the first possible point where some test can detect it. Screening test can detect it. And before that, there is no test. The disease is very small. No test in the world can detect it. So A is the point where disease is onset inside the human body. And B is that point at which some test can detect it. And D is the point. D is the point. It will present symptoms. Usually it will present the symptoms, and with the symptoms, the patient will run to doctor. The patient will come to the physician. We don't go to the patient. This is usual time of diagnosis. If you don't intervene, it will grow, and it will produce symptoms in the patient. It will produce symptoms. And finally, the outcome is there. It can be good, it can be bad, depending when the patient is presenting and when we are offering the treatment, what we are offering the treatment, what is the disease, many factors. So outcome can be good, patient can recover. It can be death also. It can be bad as death. So that is the outcome. Now let's talk about point C. Point C is the final critical point. You will say, ma'am, what do you mean by final critical point? Listen. Now I want to diagnose the disease before this point, before the usual time of diagnosis. This is the usual time of diagnosis. If no one does anything, patient will naturally come to you. Doctor, I am having some problem with the signs and symptoms. I want to diagnose before that. Before the patient presents with symptom, I want to do the diagnosis and treat the patient. But I cannot do the diagnosis at onset. This is the first possible point I can do the diagnosis. Because before that disease is very small, there is no test available, I can do the diagnosis. So between point B to D, I want to do the diagnosis before usual diagnosis and after the first possible point. This is known as lead time. What it is known as? Lead time. Say what it is known as? Lead time. So what is lead time? The point between B and D. Say the definition. It is a distance between 2 points. The first possible point of detection and the usual point of detection. So the time between the two is known as lead time. Got my point? Say something. Now in the lead time, is it the case? Let me ask you a question. Is it the case that anywhere you can do the diagnosis and treat it, prognosis is better as compared to patient coming at usual diagnosis and you are giving the treatment? Imagine my patient is coming at D. This is the D point. Come to me, doctor, I'm having some problem to me. So I will offer a treatment, but patient is already so late. Patient is in stage 3 or stage 4 of cancer. Already so late. But I will give the best treatment available to me, chemo, radio, whatever. But prognosis is not very good. So I wish कि अगर तुम मेरे पास पहले आए होते, if you come to me earlier, you can have a better prognosis. But unfortunately, you are already very late. This is point D. Now I want to diagnose before and treat before so that the person have a better prognosis. What is the use of early diagnosis? Diagnosis is not important. Before this point, I want to diagnose, but I want to diagnose before because I want to treat before, because I want a better prognosis. Ultimate purpose is to change the prognosis. Ultimate purpose, I want to give a better prognosis to that person. है ना कि पहले डायग्नोस हुआ होता तो आज जिंदगी कुछ और होती, वो बात है ना. सो दैट्स व्हाई आई वांट टू डू द अर्ली डायग्नोसिस. इज इट कि कभी भी लीड टाइम में डायग्नोस कर लो तो प्रोग्नोसिस सेम है? नो. Lead time ka bhi first half is important. This is a critical point. See, in the lead time, you can see there is a point C, critical point. You can see. So before critical point, if you are doing the diagnosis and giving the treatment, the prognosis is better as compared. You are giving the treatment here and the prognosis is. And if you are treating between C to D, prognosis is same as that you are treating after D. So there is no use na kharcha kyun karu? Why to waste time, energy, and money? Ultimately, I want to do a investment. I'm investigator. I'm applying pap smear in all the females available in India. All the females who are more than 20 years. So kitna kharcha aayega? How many females are there in India? There are in billions. Come on, more than 20 years. Billion of females. I require billion of pap smear. So I will do that. So it is a big investment. But why I'm doing so? Why should I do so? Because if any female has just started the cervix cancer but not yet presented, I want to detect that. Because usually when the female will present, it's already too late. I want to detect it early and give a better prognosis, better life to the female. I know. So I'm investing my money, energy, time. I know. I'm investing all. So ultimately, I want a better prognosis in the females in which I'm doing the early diagnosis as compared. Usually, they all will present. So if it is before point C, the prognosis is better. If it is after point C, the prognosis is as usual as after point D. How many of you got the point C relevance? That's why it is known as critical point. How many of you got it? Say something. Say either yes or say no, but say something. Respond, people, respond. Anyone who didn't got what is critical point? Anyone who didn't got what is critical point? I guess everyone got it. If anyone have trouble, please write down clearly. Everyone got it. What is critical point? I'm repeating once again, the last time. You can see, I have cleared the diagram. You can see. So the distance between B and D is the lead time. Lead time is the time between the first possible detection and the usual diagnosis. Usually the patient presents with symptom. The lead time is not useful. The first half of the lead time is important. So first half of the lead time between points B and point C. This is known as screening time. I want to apply screening test in the first half of the lead time, so that if I can do the diagnosis here, the prognosis is much better as compared to point D after. If I'm doing the usual prognosis after presentation. So here the prognosis is much better as compared to here. And if I'm doing the diagnosis and treatment after point C, but before D, so prognosis is same as that of this. So what is the use? There is no use ना. तो patient को ही आने दो, हम काय को जाएं इतना खर्चा करें, मैं इतना जाऊं इतना खर्चा करूं इतना सब करूं, तो मतलब है कि पेशेंट को फायदा हो, उसका प्रोग्नोसिस बेटर हो. अगर यहाँ का प्रोग्नोसिस यहाँ का सेम ही है, so let the patient present and come. Why I should waste my money and energy? I want to waste only in that case if I can do the diagnosis before C. This is the most important point if you all got it. Okay, got it. So this point is known as screening time. So can I say the first half nahi portion, the first portion of the lead time is screening time, not the later portion. The first portion, है ना? So Simba, I want to say that if you are treating the patient between B and C, है ना? And if you are treating the patient between C and D, and if you are treating the patient after D, which is having best prognosis? So I say here the prognosis is usual prognosis, but here also the prognosis is same as that of that. So what is the use? What is the use of doing it before? Let the patient present. I want a better prognosis, which is possible here only. The prognosis is better if you do it in early portion, not in later portion. This is the summary. Got it? How many of you got it? So this is known as screening time. So define screening time, say BC. Define lead time, BD. So first half of lead time is screening time. Okay, so some diseases the lead time is very small. Small maybe the first portion is still very small, so it's not possible to do the screening test in that time. So screening test is useful only in those diseases which is having a big lead time. Say it again. Screening test is useful only in those diseases which is having a big lead time. It's a PYQ. Okay, I hope you all got it. Jitni audience utni thumbs up. Say something. So what is screening time? It is the distance between first possible detection and the final critical point. And what is lead time? It is the distance between first possible detection and standard diagnosis. Lead time is the advantage gained by screening. Anna, bigger is the lead time, better is the screening. I hope everyone got it. Anna, so you have to understand this diagram, I guess. Anna, so screening test is not useful in the diseases which is having less lead time or no lead time. Screening test is useful only in those diseases which is having long lead time. You can understand, more is the lead time, better is the chances you can detect it in early half and treat it and having better prognosis. Okay, Anna. So this is the complete story of the screening diseases. So tell me the answer. What is lead time? Can you define what is lead time? Read the 4 option. What is lead time? Tell me fast, quick. Is it the disease onset and first critical diagnosis? Is it disease onset and first point of detection? Is it between first point of detection and final critical point, or first point of detection and usual time of diagnosis? Let's see who is first. Aditi and Megha are first to answer. Very good, girls. Very good. What about others? Everyone answer, please, fast. Come on. Yes, yes, you all are right. You all are right. Yes, the correct answer here is D. Anna, it is the first point of detection. You cannot diagnose the disease at the onset. There is some distance. So first possible point of detection till usual time. And if I change the question, current answer is D. If I change the question from lead time to screening time, would you like to change your answer? Of course, you must. In that case, what is your answer? Fast, fast, people fast from the same 4 options. What is your answer now? Screening time kya hai? The first portion of the lead time. So in that case, your answer, very good, Pritesh. Very good. Others? What is the answer in that case? So first possible point of detection to final critical point. In that case, your answer is C. Now, if you have an understanding, then only you can answer everything. Otherwise, it will be a simple rectification. You cannot answer. Okay. There are 2 types of screening: prospective and prospective. Prospective is for patient's own benefit, and prospective is for others' benefit. For example, I am screening for cervix cancer. No, the lady don't have any symptom, but I insist if any female more than 20 years of age, now every 2 years, the screening pap smear should be performed. Anyone can have cervix cancer. Cervix cancer is the most common cancer in India. It's a screening test. The healthy people, we are performing on healthy. So they think they are healthy, but actually they are not healthy. We want to detect that only. Okay. So it is for own benefit. If we diagnose the cervix cancer at early stage or breast cancer at early stage, it is useful for the patient only. They will have better prognosis. But imagine I'm doing screening for HIV. The person already have the HIV. Now what I will do, I will ask the person the sex history, the sexual intercourse history. So all the sexual partners I will trace. I will trace all other sexual partners and I will treat them as early as possible so that they don't have sexual intercourse with others and the chain continues. I want to prevent others. This is for others' benefit I'm doing. Unko to ho gaya. They already have the HIV. I do not want to spread it to the community. For others' benefit, it's prospective. So screening is of 2 types: prescriptive, prospective. Say it out. Prescriptive is for own benefit. For example, early diagnosis and detection of cervix cancer, breast cancer. Prospective is for others' benefit. For example, I told you HIV, TB. So we will trace it for others. Okay, got it? Say. So this is prescriptive is for own benefit, prospective is for others' benefit. Okay, so that is the main thing. So can you tell me, read the 4 example, which of the following is an example of prospective screening? Pap smear in a 40-year female, neonatal screening for hypothyroidism, screening of immigrants of a country, or screening of sugar in a 40-year-old male. Which of the following is an example of prospective? By prospective, I mean the benefit for the others. Which of them is benefit of others, not themselves? So cervix cancer may, pap smear may, it is for own benefit. Now the female will have the benefit. Diabetes, we are diagnosing sugar. So diabetes we own benefit hai, early diagnosis denge. Neonatal screening hypothyroidism, ये भी neonate का own benefit है. But we are screening the immigrants. What are immigrants? The new people coming in your country, right? So we are screening them for our country people so that they do not carry any disease from other country. Like during COVID, the international airport, we were doing the screening of the immigrants. So any person with COVID positive cannot travel from one country to another. This is for the benefit of their country people. COVID positive patient they don't allow in anyone's country. So this is the immigrant, not for jisko hai wo to ho gaya, but for others' benefit we are doing. Okay, can we go ahead? Okay. It can be done for any diseases. Yes, contagious diseases, Megha, you can say. Okay, usually contagious diseases, of course. Okay, so that is the thing. And that is the first classification, prescriptive, prospective. There is one more classification of the screening. Mass screening, it is done on all the people throughout the country. Very costly, it is not good. very costly, है ना? It is not effective, very good, because not a good idea. You cannot afford that in billions. Okay, better to do high risk screening. So if you want to screen for lung cancer, don't look in all. Look only in smokers. Smoking is a risk factor, no? So your cost reduction will be there. I cannot afford to do lung cancer screening in all the persons in India, but the smokers I can do. है ना? The same way I cannot rule out ischemic heart disease or screen ischemic heart disease in all the person, but I can test for hypertensives, I can test for obesity, है ना? Like that. Okay, so mass screening is the screening which is performed on whole population, irrespective they have respected or they don't have. है ना? So it's not very useful for preventive because it's very costly. High risk is done only on risk group, as I told you the example. Multiphasic screening means multiple screening tests is performed in one individual. Best example is health checkup. Do you do your health checkup, annual health checkup? In annual health checkup, everyone should do that. है ना? So all the blood tests are done. Although the person is healthy, we all do our annual health checkup, our parents' annual health checkup once in a year or two, like every 2 years it should be done. So multiple screening tests are performed there. And the opportunistic screening, it is the screening of a patient who consult the doctor for some other purpose. You are taking the advantage of the opportunity. For example, I'm a gynecologist and a lady coming to me. Of course, ladies will come to me too because I'm a gynecologist. For example, so with some complaint, she is coming. She's having some gynec problem or she's having some obstetric thing. She's pregnant, है ना? So I will deal with that complaint. But I find the lady is very obese and she is diabetic also. She is hypertensive also. So I'm afraid that in future she may have ischemic heart disease. But I'm not a cardiologist. Why I should get afraid? So if she have ischemic heart disease, the cardiologist will deal that she is having a heart attack. Am I? And cardiologist का problem है वो lady का problem है, but it should not be the mentality, right? You treat your disease, but you take the opportunity and you should screen for that, है ना? So you should screen for that. Okay, if you see any risk factor, you can do the screening. You should counsel the lady that you should lose your weight. Anna, you should do physical activity. You are already obese, you are diabetic, and in future you can have heart attack, you can have MI, you can do the screening. Okay, like that. You can ask to perform a treadmill test and other tests which are used for screening of the MI. Okay, so she can perform because they are laymen, they don't have medical knowledge. If you advise them, they can follow. Okay, this is opportunistic screening. Anyways, let's move ahead. Criteria of screening test not important. So, okay, criteria of screening test. Whatever screening test you are applying, it should have four things. It should be acceptable to the people. It should be repeatable. It should be valid. It should be others. What is acceptability? Whatever screening test you are applying the people who think they are healthy. And it's very difficult to apply test on healthy people. Diseased people, it's very easy. Diseased people, they are already in trouble. They will run to your doctor. I'm having some problem. Do some test and treat me. So it's very easy to perform test on them. They will cooperate. But imagine a healthy people. You are asking them to do some test. They will say, no, 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 I'm healthy. Why should I perform the test? They will say, no, no, it's free of cost. Still, they will say, why should I perform? Still, it's free, but I will not participate. So it's very difficult to convince them. And still, usme bhi accept hona chahiye. Like some tests involve like digital rectal examination. It's not very comfortable to allow someone like to do the digital rectal examination in males for prostate cancer. Sometimes it's embarrassing. Someone is very shy, not feeling comfortable with that test. So healthy people will not at all cooperate. Diseased hoga to cooperate karega. Of course, the person has to cooperate, no other choice. But healthy people, they don't cooperate at all. Hana? So it should be acceptable to the people. Okay, number one. Number two, it should be repeatable. It is not every time it is giving different result. The same result should come every time if you are repeating in the same person. Number three, it should be accurate. है ना जो result है वो valid होना चाहिए. It should be accurate होना चाहिए. So it should be acceptable. It should not be embarrassing. It should not be painful. Because people are healthy, they think they are healthy, है ना? They will not cooperate. It should be repeatable. It should be valid. Okay, it should be simple. It should be rapid. It should be cheap. It should be safe. It should be easy to administer. These are the qualities. Okay, got my point? Can we go ahead? Okay. Tell me, you know the answer. Ideal screening test should be. It should be safe, reliable, valid, all of the above. I guess everyone knows the answer. It should be all of the above. I told you the properties. Okay. Now let me come on the most important topic of this chapter. The four properties of a screening test. You all got it. What is screening test? Now let me tell you the four properties of a screening test. Huh? Sensitivity, specificity, positive predictive value, negative predictive value. Sensitivity, specificity, positive predictive value, negative predictive value. Very difficult to understand. Easy to mug up, but difficult to understand. So I will try my best to make you understand. Okay. So for this, you have to make a table. You have to make a table. Imagine I'm having a group of people. This is my group of people standing in front of me. I'm having 100 people. They all think they are healthy. They all think they are healthy, right? So let's apply a screening test on all of them. If I apply a screening test on all of them, they are divided into 4 groups after the result. Hana? Some are actually having the disease inside them. They don't know they have the disease because they don't have symptom, and test is also positive in them. We want that, yes. So test should detect such person who have disease inside them. These are known as true positive. Okay, some are the people who don't have disease inside them and test is negative in them. We want that key. These are the real healthy. They don't have disease inside them, not even very minute, and test is not detecting. Test is saying they are negative. So these are the true negative. True negative means these are real healthy. These are apparently healthy. These are real healthy. So ideally, the 100 people should be divided in 2 columns. But no test is perfect in this world. Even Carnot engine is not 100%. Nothing in this world is 100%. Not me, not you, nothing. Everything has some flaws. It's a rule of nature. It's a rule of universe. We all have some flaws inside us. Everything. Nothing is 100%. It is a universal law. So test is never, none of the test is 100%. Now mistakes are always there. So there is a mistake. There are some persons who have the disease, but galti say, by mistake, the test is saying they are negative. Ideally, test should say it's positive. And there are some person who don't have disease. So ideally, test should say you are negative, but the test results are positive in them. No, these two are unlucky people. These type of people are unlucky. I mean, these are known as false negative. False negative means they are falsely negative. Actually, they are not negative. They are falsely negative in the test. And these are known as false positive. They are not actually positive. They are falsely positive. Actually, they are negative, but they are falsely positive. You got my point? Imagine which is more unlucky in them. Both of them are unlucky. These are the lucky one. We are doing early diagnosis and treatment. Very good, Hannah. They have the disease. It's their bad luck. God has given disease to them. But we are doing early diagnosis. Before the symptom present, we will treat them. The prognosis will be very good. So in this way, they are lucky. And these are the ultra lucky, super lucky. They don't have to do anything. Repeated screening every year they should do. Hannah, they should go to their home. These are true negative. But what about these two? Anna, see their life. Anna, they have the disease. The test result will be negative. So at that time, they will be very happy. Oh my God, I'm negative. Yes. I was knowing that. But after some time, they have the symptoms. So at that day, when they have symptom, वो बोलेंगे कि अरे उस दिन test भी तो negative आया था. Imagine a lady has cervix cancer. She has done pap smear just few months back. So she say, I have done the pap smear also. It was also negative. How I can have the cervix cancer? Anna. So she is that. Anna. And these are the people, they don't have the disease. Just a second. Who is this calling again and again? Anyways, so the test is, they don't have the disease. Just a second. They don't have the disease, but the test result is positive in them. Okay. I mean, they will be like, they will be positive. So at that time, they will be tense. And unnecessarily, they will get the treatment. They don't require treatment, but unnecessary. But although before giving the treatment, we will confirm with diagnostic test. Diagnostic test will be negative in them. So you can understand the four categories. How many of you got the 4 categories? So you have to make this table. This table is master table. Please understand. Please. On the top, you always take disease. It's a rule. And on the left hand side, you take the test result. Hannah. So always say disease at the top. Always say disease at the top. And always say test result at the left hand corner. Test result at the left hand corner, and make 2 by 2 table. Make 2 by 2. Let me tell you what is the meaning of 2 by 2. I'm making a 2 by 2 table. This is known as 2 by 2. 4 columns are there. 2 by 2 table. Listen. Say disease positive, disease negative. Test result positive, test result negative. Always it's a rule. Hannah? So you can see, let me write ABCD. This is A, this is B, this is C, this is D. Let me explain you the meaning of that. Everyone on the screen, everyone. A are the people who have the disease and test result is also positive. These are true positive. Hannah? They are the lucky one. Early diagnosis treatment we will offer. D are the person, they don't have the disease and test result is also negative. These are true negative. These are super lucky. No, they don't have disease. They will go back to their home. They are very happy. Okay. What about B and C? What about B? The irony is there. B and C, they are not lucky. Okay. What about B? They don't have the disease. Actually, they are negative. But galti se test results are positive. So I will call them false positive. B is false positive. Falsely, they are positive. Actually, they are negative. It means that. What about C? What about C? They don't have the disease. Oh, I'm sorry. They have the disease. They are positive. But galti se test is giving negative. These are false negative. They are not actually negative. They are falsely negative. Say yes. So always say A and D. A and D is very easy. Please learn. Please everyone learn this table. Everyone on the screen, concentrate. So A is always true positive and D is always true negative. In true positive, both the things are positive, disease as well as test result. In D, both are negative. These are true negative. There is no problem in that. The problem is here and here. है ना? So B is false positive and C is false negative. है ना? If you understood how to make this table, it's good. If you don't understand, learn it. Learn ABCD. So what I told you, I will tell you once again, make a 2 by 2 table. So 2 by 2, this is how we make a 2 by 2 table. In the 2 by 2 table, at the top, we always write disease. And here we always write test result. Last time I'm telling you, please concentrate. Positive, negative, positive, negative. First positive, then negative. It's a rule. Then you can say this is A, this is B, this is C, this is D. You can label A as true positive. Both are positive, you can see. And D is true negative. Both are negative, you can see. And B are false positive and C is false negative. Say yes. How many of you got it? Okay, don't say how many of you got it. So say how many of you didn't got it. Tell me what is ABCD. Hana? What is A, what is B, what is C, what is D? Now I will tell you 4 things here. Sensitivity, specificity, positive predictive value, negative predictive value. Say, ma'am, okay, you tell me in each of them, disease present or absent, and in each of them, you tell me test result, positive or negative. You tell me. So A are true positive, TP, true positive. Disease present, test result is also positive. D are true negative, very simple. Hana, true negative. No disease, test result is also negative. What about B? They are false positive. False positive means test result is positive, but falsely positive. Actually, they don't have the disease. And C are false negative. I mean, the test result is negative, but it's falsely negative. Actually, they have the disease. Respond, people, say, deaf and dumb people, fast. So kindly respond. You got it or you didn't got it? Give me a gesture so that I can proceed. If you got this, I am ready to proceed with sensitivity, specificity, positive predictive value, and negative predictive value. No one is responding. Am I live? Visible, audible? Okay, got it. Elizabeth, yes. Megha, Aditi, doxycycline, Devbatra. Thank you for responding. Thank you so much. Thank you. So I guess most of you got it. No one is having any trouble. So let me tell you 4 things here only. Okay, what is sensitivity, specificity, positive predictive value, negative predictive value? Everyone on the screen. Listen, let me write here sensitivity and specificity first. Okay, let me tell you the formula of both of them. Okay, so sensitivity, see, sensitivity, what's the sensitivity of a test? Out of the total persons who have disease, who have the disease, you tell me? Total, you will say, man, disease is present in A plus C. Total. Actually, test should give all of them positive, but test is saying positive only to A. C छूट गए गलती से, है ना? So out of the total person who have the disease, how many actually given positive by the test who have the disease? So A upon A plus C is sensitivity. The definition, it's a tendency of the test to detect true positivity. That is known as sensitivity. Sensitivity is true positivity. Okay, so if you say the formula here, if you see the formula, see, the formula here is, you can say A kya hai? True positive. Upon true positive plus, what is C? False negative. If you try to mug up, you will forget. Better learn A upon A plus C. लेकिन उल्टा पुल्टा मत करना. Learn ABCD. Better to learn ABCD. है ना? A upon A plus C is sensitivity. If you understood, it's good. Don't understood, learn the formula. A upon A plus C. Very simple. You know what is ABCD. Okay, specificity is a tendency of a test to detect true negativity. है ना? Actually, who all are negative? You tell me who all are negative. Negative means they don't have disease. Who all are negative for disease? You will say, ma'am, B plus D. They don't have disease. So ideally, they all should be negative, but test is saying only D is negative. D is negative. So out of the B plus D, only D are negative. So D upon B plus D is specificity. And if you say the formula in terms of true. So this is true negativity upon true negativity plus false positivity. Anna, but if you try to mug up, you will forget. Better to learn what to learn. Better to learn A upon A plus C, D upon B plus D. These are the formulas of sensitivity, specificity. How many of you got it? Shall I say positive and negative predictive value? If you got this, how many of you got this? Let me erase it. Learn it. If you got it, it's good. If you didn't got it, it's double good. Learn it. No one in the exam is going to ask the concept. Ultimately, answer should be right. Okay, ji? Anna? So let me come on positive predictive value and negative predictive value on this page only. Anna? Numerator and denominator you have to say. Okay? Anna? Please concentrate. Listen. Now, what is positive predictive value? Listen. Now, out of the test, who's saying positive to all? How many are positive in a test? Where is test? You can see the table. Where is test? How many people the test is saying positive? To how many people? The test is positive in A plus B, but actually disease is present only in A. So out of the total, the test is saying positive. How many actually have the disease? A upon A plus B. Hana, A upon A plus B is the thing. Okay, got it? And out of the test, out of the people in which the test is saying negative, it's total C plus D. Hana, how many actually don't have disease? It's D upon C plus D. Okay, ji, hai na? If you say in the terms of true positivity, true negativity, you can make out that formula also, I guess, hai na? So if you try to learn that, you can confuse. So this is true positivity upon true positivity plus false positivity. This is true negativity upon true negativity plus false negativity. So don't learn that. Learn ABCD. Hai na? On the next page, I'm writing again. Okay. Where is the table? This is my table. Okay, here only I will erase and do that. Give me a minute. Let me erase everything. Can you give me a minute to erase everything? Or okay, we will take next page. It's okay. Okay. So, okay. Sensitivity, specificity, positive predictive value, negative predictive value. Okay. Rather, I must write like this. I would like to write sensitivity and positive predictive value together, and specificity and negative predictive value together. Okay, like this. Anna, you have to tell me the denominator mainly of all of them. Okay, please understand. Sensitivity and positive predictive value, they have a tendency to detect the true positivity. So numerator is always A in both of them. And specificity and negative predictive value, they have a tendency to detect the true negativity. That's when numerator is always D. Numerator is not a problem. The problem is the denominator. Anna, you must understand the denominator. Okay, can you please tell me the denominator? Elaborate the denominator. Here A plus C, here B plus D. Here A plus B, here B plus C. If you understood, it's good. If you didn't understood, you have to learn it. There is no other choice given to you. How many of you got it? Now, in terms of this thing, true, positive, true, negative, you can write. You know what is ABCD? Say, what is ABCD? Say, A is true positive, we all know. D is true negative, we all know. ये तो सबको पता है. B is false positive and C is false negative. Learn that. Now replace ABCD with these terms. You will get 4 more formulas. So you will get true positive upon true positive plus false negative. Here you will get true positive upon true positive plus false positive. In the same way, you will get the formulas here also. I don't learn these formula personally. I forget because it creates confusion in my mind. What I used to learn is these formula. Rather, I don't learn these formulas also. Frankly speaking, I don't learn any formula. Frankly, I know the table. If I know the table, no need to learn the formula. Why any need to learn the formula? I know to make the 2 by 2 table. This is a 2 by 2 table. If you don't want to learn anything, it's okay. See here on the screen. Make a 2 by 2 table. How to make this table? You know the rules. Write disease at the top and write test result at the left hand corner. Positive, negative, positive, negative. If you can do so, you have to write ABCD. This is always A, this is always D. This is always B, this is always C. If you are right, don't change anything. Write like this. Write down their other names. This is true positive. This one is true positive. This one is true negative. This one is false positive. This one is false negative. You can make it out. Okay. Now, when it comes for writing the formula of sensitivity, specificity, positive predictive value, negative predictive value, it's very easy to say the denominator. You know the numerator. You already know the numerator. There is no trouble in numerator. You know the numerator of sensitivity and positive predictive value is going to be A. It's true positivity. And numerator of specificity and negative predictive value is going to be D. And it's true negativity. The denominator is a trouble now. So there is no problem in that. Listen how I am going to write the denominator. For sensitivity and specificity, here the denominator is A upon C and B upon D. For this is sensitivity, this is specificity. Got it? So here A upon A plus C and B plus D. This is how I go. This is how I go. And for positive and negative predictive value, how I go? This is A upon A plus B and C plus D. It's very easy if you learn. It's A plus C and C plus D. It's like that. And you know what is true, positive, true, negative. You can, every time you can replace. Say yes, say something, respond. Say, come on, say. Got it? Can we go ahead? Huh? You don't have any problem in understanding? Okay, so these are the 4 formulas I told you. I guess everyone got it. Anyone having any trouble, please say it. Otherwise, there are 4 formulas I told you. I know the same thing is written in front of you. You can read what is A, what is B, what is C, what is D, what is true positive, what is true negative, what is false positive, what is false negative. You should know their definition. You can understand this graph. This is the cutoff of the disease. You can see this is the cutoff. A is the cutoff. Just suppose my sugar is, I take the cutoff as 100, blood sugar. Below that, the person is non-diabetic. Above that, the person is diabetic. I mean, below 100, if the fasting sugar is below 100, I will say the person is healthy. And above 100, it can be anything. Just blood pressure, 120 by 80. Below 120 by 80, the person is healthy. Above that, the person is hypertensive. So there should be a cutoff. So all the persons below this cutoff, you will see, ma'am, healthy. All the persons above the cutoff, it's disease, but it's not always black and white. The gray is a trouble. In medical science, the gray is always a trouble. What a beautiful world if everything is black and white. There is no gray, but gray is always there. You can see here. Please see this portion. This portion of the people. Can you see? They are actually healthy, but they are above the cutoff. They are falsely positive. They don't have disease, but by mistake, the test is positive in them. And see this group of people, this one. They are below cutoff. The test is negative in them, but actually they are diseased. So they are false negative. And these are true positive, which are above cutoff. These are true negative, below cutoff. C, A, B, C, D. So can I say this is A, true positive? Can I say this is D, the true negative? Can I say this is B, false positive? Can I say this is C, false negative? So label A, B, C, D on the graph. You can get a question on that. How many of you got it? How many of you got it? Beautiful concept. So understand the 2 by 2 table, understand the graph, and learn the 4 formulas. That's it. That's it you have to do. I know you got it. So, okay. Okay. So we have done. So sensitivity, specificity. I told you what is sensitivity. It is a tendency. It is the ability of a test to detect the true positive. Okay. I told you the formula also. Just a second. It is stuck. Okay. So you can see the 4 formulas are written. Sensitivity, specificity, positive predictive value, negative predictive value. If you know what is ABCD, just learn the formula, as simple as that. Into 100 in all of them, because we calculate all of them in percentage. Do into 100 in all of them. And learn the formula in terms of true positivity, true negativity, false positivity, false negativity. If you know what is ABCD, you can easily replace it. Anytime you can do the replacement. So I suggest you to learn these formula and replace them with true positive, negative, false positive, false negative. That's it. That is more than sufficient. So I will show you. And yeah, one more thing. Sensitivity is inversely proportional to specificity. Both cannot be. Sensitivity and specificity is equal to 1. So sensitivity is equal to 1 minus specificity, and specificity is equal to 1 minus sensitivity. Learn it. Sensitivity plus specificity is always 1. The sum is 1. So one of them is equal to 1 minus another. Sensitivity is equal to 1 minus specificity. Specificity is 1 minus sensitivity. So they are inversely proportional to each other. Finally, I concluded. The test having more sensitivity have less specificity. The test having less sensitivity have more specificity. What I want in my test, ideal test should be 100% sensitive, 100% specific. But there is no such test. There is no such test in this world. There is no 100%. Now, Carnot engine is not 100%. कोई भी 100% नहीं है. None of the test is 100%. They can be as high as 90, 95%, but they are not 100. Okay, so please learn that. Okay, and after that we have seen positive predictive value also. So so ideal test should be 100% sensitive, 100% specific, but it is not there. Sensitivity is inversely proportional to specificity. This is also I have given. Okay, Anna, tell me the formula of sensitivity and specificity once. Can you please tell me once? Last time. What is sensitivity and what is specificity? We will write it here. Sensitivity is equal to A upon A plus C. That is true positive upon true positive plus false negative. Am I right? If I'm doing any mistake, please clarify. Specificity is equal to B upon B plus D. Okay, that is true negative upon true negative plus false positive. Am I right? I guess I'm right. And sensitivity and specificity are inversely proportional to each other. You can see sensitivity is directly proportional to true positive and inversely proportional to false negative. So same thing. If sensitivity is more, true positive is more, but false negative is less. And specificity is directly proportional to true negative and inversely proportional to false positive. So if specificity is more, true negative is more, and false positive is less. No need to learn nothing. कुछ load मत लो. Formula में visible है. It's visible. You can see this is directly proportional, this is inversely. This is directly, this is inversely. You just write down the formula. Don't use your brains. It's like mathematics. We don't learn the numericals in mathematics. We solve them on spot. Anna, say, got it? So this is the thing also I have explained you. Okay. So can you read the question and tell me the answer, please? We will solve some numericals. We are done with this chapter also. Okay. Read the question. The probability of a test to detect true positivity. The probability of a test to detect the true positivity persons from the population of a disease is what? Is it sensitivity, specificity, positive predictive value, or likelihood ratio? I'm asking you people. What is the correct answer? Yes, absolutely right, Aditi. Absolutely right, Leah. Absolutely right, Navjot, Prabiggal. Absolutely right. Okay, you all are right. Yes, the correct answer is sensitivity of the test. Very good. The tendency. If I change one word to positivity to negativity, the tendency to detect true negativity, answer will become specificity in that case. Okay, the next question. Ability of a test to correctly diagnose the percentage of the sick people, I mean, who are having the condition is known as. So same question I'm asking in a different language. The sensitivity, the ability of a test to correctly diagnose the percentage of the sick people, Anna, means true positivity out of the total diseased person. So again, in a different language, I'm asking the sensitivity. What is false negativity? What is false negative? Read the four options carefully. False negative kaun hote hain? I'm asking false negative are C, I guess. A, B, C, D. Yes, C are false negative. So I'm asking what is the definition? The person who have the disease but test is negative. The person who don't have the disease but test is negative. The test, he who have the disease and test is negative. Who don't have the disease and test is negative. The person who have the disease but test is positive. The person who don't have the disease and but the test is positive. What is the correct answer? What is false negative? False negative means test is negative. Test is negative. Actually, the test is negative, but it's not actually negative. The person have the disease. You all are right. The correct answer is A. I guess the correct answer is A. You all can make it out. I have explained you very clearly. I know. So in this way, you get question on all of them. So I will keep on changing question 4 times. The answer will change. If I instead of false negative, if I ask you the true negative, answer will become B. Okay, if I ask you true positive, answer will become C. This is the definition of false negative. This is the definition of true negative. This is the definition of true positive. This is the definition of false positive. You can make it out. Negative positive, I guess. So if I keep on changing the question, the answer will keep on changing. I'm not changing it again and again. You got the concept. So you get questions on that. Okay, Hannah. What is the numerator of sensitivity? Numerator of sensitivity. Is it false positive, false negative, true positive, true negative? Tell me the formula. Tell me the formula. Always learn the formula. A upon A plus C. What is the numerator? You all can see. Numerator is A. What is A? What is A? Huh? Yes, absolutely right, Elizabeth. Very good, very good. So A is true positive. So correct answer is true positive. The correct answer is D. They are asking the numerator. If instead of sensitivity, if I change the question to specificity, what is the formula of specificity? Specificity is D upon B plus D. So what is the numerator there? Their numerator is true negative. In that case, answer will become C. Anna. So this is how you get simple questions on the formula. Learn the 4 formula blindly. Just learn it. Just learn it. Positive, negative predictive value also I taught you. The positive predictive value and negative I have explained what does it mean. So I'm not reading the theory. No need to read the theory. Just learn the 4 formula. Ultimately, you have to learn these 4 formulas. Okay, Ji. These 4 formulas are everything. You can see I taught you 4 formulas. Sensitivity, specificity, positive predictive value, negative predictive value. Learn the numerator and learn the denominator. That's it. A upon A plus C, D upon B plus D, A upon A plus B, D upon C plus D. That's it. Anna, got my point? So I'm okay. Tell me the answer. For calculation of positive predictive value, the denominator is what? Can you please tell me the denominator? What is the denominator of positive predictive value? Who will tell me the denominator, please? Tell me the formula. Positive predictive value का formula क्या है? The numerator is A, like sensitivity, but denominator will be A plus B. So tell me what is ABCD? You will say, ma'am, A तो होता है true positive upon true positive plus B क्या होता है? False positive. So true positive plus false positive. So true positive plus false positive. I guess the answer is C. Why people are saying B? Some people. The answer is C. Okay, everyone got it. So in this way, I keep on changing the question. इसी question को मैं positive को negative कर दूं तो answer कुछ और होगा. Sensitivity में कुछ और. Specificity 4 time options I will change. 4 answers will be there. So 4 options are: 1 sensitivity, 1 specificity, 1 positive predictive value, 1 negative predictive value. I hope you all got it. So everything here, everything shown here is the 4 formulas only. You have to learn ultimately 4 formula. That's it. The gist of the chapter, the 4 formulas, the 2 by 2 table and the 4 formula. Anyone having any trouble in understanding, please? Read the question, tell me the graph. You can see there is a graph given to you. It is an image-based question. A graph shows curve of normal blood sugar level. This is normal blood sugar level. We consider normal blood sugar 120 milligram. Below that it's normal, above that it's disease. Okay? Hai so diabetic blood sugar level is shown below. Okay? Some areas found to overlap. You can see. So they are asking you, what does the D represent? They have done a labeling. C, A, B, C, D. Where is D in the graph? They are asking what is D. You tell me what is ABCD चारों. फिलहाल D क्या है वो बताओ. This D, this area. What is this area? I'm asking. What is this area? You're asking D. What is the correct answer? Huh? So of course it's not true, positive, true, negative. Answer will be from false, positive, false, negative. So yes, the correct answer is they are false, negative. Okay. And if I change the question, what is A? What is A? Okay, let me write. A are true, positive. B is true, negative, because they are above and below the cutoff. Above the cutoff is true positive, below the cutoff is true negative. उसमें तो कोई problem नहीं है. Overlap is a problem. So this area D is false negative and this area is false positive. Now you can imagine same graph you can get 4 questions. They can ask you any area. What is A, what is B, what is C, what is D? Or rather to confuse you, they can ask all of them. A, B, C, D. Match the column. Something can be created like you. You got it? If you have the concept, you can answer. Say, learn the 4 areas. That's it. I want you to learn the 4 areas. There is no problem in true positive, true negative. उसमें किसी को problem नहीं होगा. Above the cutoff, it's true positive. Below the cutoff, it's true negative. किसी को problem नहीं है. Problem is the shading, the overlap. Learn the overlap. है ना? So you can say this one is A, this one is D. है ना? This one is B and this one is C. How many of you got it? Learn in terms of ABCD, the 2 by 2 table. Okay, G. Can we go ahead? Huh? Can we go ahead? Tell me, this is the graph given to you. This is the 2 by 2 table already given to you. You don't have to make. But whenever, beware, table, they already given a check whether it is standard or not standard. Disease at the top and test result at the left-hand corner. Sometimes they give the inverse. They give test result at the top and disease at the left-hand corner. So everything ABCD will ulta-pulta. A will become C, B will become D. Sab kuch ulta-pulta ho jayega. So first check. So is it the same table we used to draw? Yes. Person with disease, person without disease. So disease present, absent. Test result positive, negative. Yes, it is the same table. Thankfully, they have not confused me. So A, B, C, D. They are asking A upon A plus B kiska formula hai? Now you tell me A upon A plus B kiska formula hai? You tell me. A upon A plus B is the formula of positive predictive value. Okay, yes, we know that. So correct answer here is positive predictive value. In the same way, I can twist the same question 4 times. You know, how can I twist? I will keep on changing the formula. The answer keep on changing. I'm not doing so. You already know what I will do. Okay. Okay, can I go ahead? Numericals, I will just show you. I will not solve. I will just show you. We are ending the chapter. Okay. I will show some numericals to you. Read the question. You have to tell me whenever such question will come. Now, see the 4 options. Sensitivity, specificity, positive predictive value, negative. You have to calculate that. Without 2 by 2 table, I will not touch the question. Okay. So make a 2 by 2 table. Follow my instruction. Listen, make a 2 by 2 table. 2 by 2 table is a gist. If you can tell me the value of ABCD, that's it. Nothing. फिर तो formula apply करके it's mechanical काम. है ना? I'm not interested in teaching you mathematics and calculation. I'm interested in teaching you the approach. Okay. So tell me disease positive, negative, test result positive, negative. So I mean, read the question and tell me the values of ABCD. A, B, C, D. If you come on the conclusion, we can what is this 200, 200? Can you please tell me? What is this 200? 200 have the disease. It's A plus C. And the remaining 200 are free of disease. That is B plus D. Read the line again. 200 are the patients. They have the disease. They are biopsy proven disease. They have the disease. And 200 are the patients who are known to be free of disease. Okay, so 200, 200 is done. Now test show positive results on 180 out of the patient with disease. Out of the patient with disease, these all A plus C. है ना? The test is positive only in 180. So A is 180. So obviously C is 20. Whether they give or don't give, doesn't matter. Okay, this is a way. And negative results on 150 patient without disease. So how many patients without disease? B plus D. उसमें से negative result is 150. D is 150. So obviously B is 50. Obviously, total are 200. Now, I got the values of ABCD. I'm not interested. I know the 4 formulas. I will apply them one by one. The best thing, you should know the values of ABCD. Got it? Say yes, this is the approach. How many of you got it? How many of you didn't got it? No, I'm not interested. Please apply the 4 formula. You too, please don't do the calculation. Just apply the formula A upon A plus C, B upon B plus D, A upon A plus B, B upon B plus C. You know the 4 formula. चारों में से एक ना एक सही होगा. We will do that. There is no problem in that. The main clinch, if ABCD is right, you can do all. Got it, Hana? So this is how you have to make 2 by 2 table. If you concluded ABCD is right, you can do that. Apply the sensitivity, specificity, positive predictive value, negative predictive value. You know the 4 formulas. Apply ABCD. See the answers. One of them should be right. Of course, one of them should be right. Okay, G. This is how you have to approach. Okay, the next question is in front of you. Okay. जब भी table question में आए, whenever they give the question in the table, the first thing you check whether the table is correct or not. Sometimes they confuse you. I told you. So disease present absent. Is it the same way? Yes. Am I present? Am I absent? Am I is a disease? And the test result, positive, negative. Yes, ECG is a test. We do it in MI, myocardial infarction. So it is positive. So I can say this is A, this is B, this is C, this is D. Because table is correct. A, B, C, D are same. Just what is the question now? Just calculate the 4 things. Sensitivity, specificity, positive predictive value, negative predictive value, and see which of the following statement is correct. One should be correct, of course. Say, people, you know the 4 formulas. Okay. Last time we will make one more table and I will end it. Who all people are interested in doing this numerical with me? Raise your hands. How many of you are interested, or shall I skip it? Or shall I do it? Shall I skip it? Shall I do it? Yes. So please make 2 by 2 table with me, without which we cannot do anything. I want ABCD. That's it. I'm not interested in calculating these things. I'm interested in ABCD. Tell me the value of ABCD if any one of you can do faster than me, if you have a notebook. So tell me the values of ABCD. That is the only thing you have to do. Disease present, absent. Test result, positive, negative. Read the question and fill the values. Tell me what is A, what is B, what is C, and what is D. Okay, this is the main thing you should know. Okay, read. Total 5,000 persons underwent a screening test. I guess ABCD total should be 5,000. Let's see. Out of 500 diseased. What is this 500? Out of 500 what? 500 diseased. 300 are true positive. Out of 500 diseased. So disease is present in 500. The disease is present in 500. So this A plus C is 500. Okay, out of this 500 diseased, 350 are true positive. So this A is 350. So obviously C is 150. They will not give you the value of C. Obviously, they will give you one of the value. Okay, you got it. I guess you got it now. Hana? This is the second question we are doing with the same way. Yes. Very good. And out of the 4,500 who are healthy, out of the 4,500 who are healthy, healthy means disease absent. So disease is absent. These all are healthy. Hana? So total is 4,500 who are healthy. 3,000 are true negative. So D is 3,000. So obviously B is 1,500. Obviously, you got the values. Just do the calculation. Calculation is not my portion. Anna, I will not do the calculations. I'm sorry. Anna, so I will not do the mathematics. I know you are a better person to do that. You can apply the formula and do the calculations. Anna, so the main thing is ABCD. You can reach on ABCD. You can definitely do the calculations. Say yes. Got it? Can we go ahead? You can skip the Bayes theorem. Can we go ahead? Say something. People say. Okay. Huh? Last thing which I would like to add here, one more thing I would like to add it here. Why not to perform multiple screening tests? I mean 2 screening tests, one by one. So there are two options, test in series, test in parallel. Series means one by one. Series का मतलब क्या होता है? One by one. And parallel means together. Parallel means together. If you are applying 2 screening tests, so here first we apply A followed by B. Here we will apply A plus B together, the 2 tests. That is the meaning. So see the use. So let me tell you what is series and let me tell you what is parallel. Hana, we are applying two tests. So in series, we apply the first test, test A. So there are two possibilities. Some of them will be positive, some of them will be negative. We'll say, okay, ma'am, the one who are positive, mind my words, on them only I'm applying the next test B. Here also some will be positive, some will be negative. So at the end, the both are positive, I will consider them positive. At the end, this is also positive, this is both the test, the people who are positive here also, I will consider them only positive, not to others. So by doing so, I am increasing the sensitivity of the reaction. By doing so, I am increasing the sensitivity, so I am decreasing the specificity. So in series, we increase the sensitivity. No, शायद उल्टा बोला मैंने. By doing so, we are increasing the specificity but reducing the sensitivity. है ना? Because they are inversely proportional. This is series. Let me tell you what is parallel. In parallel, we apply them together. A plus B. A plus B, we apply them together. So there are four possibilities. 1, 2, 3, 4. What are the four possibilities? Some people will be A positive as well as B positive. Some people will be A negative as well as B negative. Some people will be A positive but B negative. Some people will be A negative but B positive. So any people who are positive in any one of them, either both of them or at least one of them, I will consider that person as positive. है ना? सिर्फ जो दोनों negative हैं, I will consider that negative. Okay, by doing so, I am increasing the sensitivity but reducing the specificity. This is the most simplified version I can explain. I cannot simplify more than that. These are the limits, I think. You got it. So ultimately, you got it. It's good. You didn't got it. You learn it. In series, we increase specificity. The other thing obviously reduce. Don't learn the other thing. And in parallel, we increase the sensitivity. The other thing obviously will reduce. Don't learn the other thing. So you will forget if you mug up, but if you can understand, है ना, one by one हम कर रहे हैं, तो हम true negativity का chance बढ़ा रहे हैं. और together, अब ये भी positive है, ये भी positive है, ये भी positive, तो हम sensitivity बढ़ा रहे हैं. Got it? How many of you got it? Say something. Respond. Got it? So this is series. This is parallel. Series one after the other. The second screening test is applied only on the individual who are positive on the first. Okay. So this increases specificity. And in parallel, all the tests applied simultaneously. Okay. This increases sensitivity. Okay. So here, specificity will increase, other will obviously reduce. And here, sensitivity will increase, other will obviously reduce. Okay, so please learn that. The same thing is written in front of you. Okay, series, parallel. Series में क्या बढ़ता है? Specificity. और parallel में क्या बढ़ता है? Sensitivity. Don't come on positive, negative value. They will not ask you. You can correlate. Okay, okay. Read the question. Tell me the answer. 2 screening tests are used in series. Then what will happen? You tell me what will happen. Sensitivity and specificity. This will increase, this will decrease. Specificity and sensitivity. Again, this will increase and this will decrease. Sensitivity and specificity. Both will increase, both will decrease. What is the correct answer? I am asking. Just now I taught you. In series क्या बढ़ता है? एक चीज याद रखो, है ना, कंफ्यूज मत हो. सीरीज में स्पेसिफिसिटी बढ़ती है, मुझे रटा हुआ है. सीरीज में स्पेसिफिसिटी बढ़ती है. तो कहाँ है specificity? Where is specificity? This is specificity increase. So obviously sensitivity will decrease. So correct answer is B. Correct answer is B. Got it? Anyone having any confusion? So this is all. And if I change the question, इस series को मैं parallel बना दूं, so parallel में मुझे एक चीज पता है, sensitivity बढ़ती है. So obviously specificity कम होगी because both are inversely proportional. In that case, my answer will become A. In that case, both increase, both decrease, ये तो possible ही नहीं है ना. Common sense, they are inversely proportional. Both cannot increase and both cannot decrease. Obviously. है ना? तो दो option तो you can rule out like this. है ना? The remaining two you have to learn. Okay, and you have to understand. Say yes. If you got it, say yes. If you didn't got it, still say yes. I mean, you ask your doubt otherwise. Otherwise, say yes. And if you have any doubt, please, you are free to ask. Okay. Okay, so let's move ahead. The last topic, the last 5 minutes. What is accuracy and what is precision? If I'm performing a test, for example, I want to measure my BP. Anna. So if you are measuring my BP, the answer is 120 by 80. Anna. If another person is measuring, there is one more person, your friend is measuring my BP, it's 122 by 82, say. Anna. And if one more friend, your friend is measuring my BP, it's 130 by say 90, whatever. Anna. So every time the result is different. No, reasons can be anything, है ना? Reasons can be inter-variable, inter-subject variable, है ना? Different persons are measuring, so they are using, they have different whatever, like method of using. The machine is not good, sphygmomanometer is not good, but every time the result is different. So repeatability is not there. Or else, every time I'm getting the same result, 120 by 80, 120 by 80. So I will say precision. Precision is repeatability. Repeatability. Repeatability is reliability. Repeatability, reliability, the one and the same thing. Precision. हर बार same result. Same result. Got my point? And what is accuracy? Accuracy यानी the exact answer. I will explain both. I will explain both. Let me show you 4 diagrams. Have I drawn the 4 diagrams? Listen. See the 4 diagrams. See here. How should I explain you? Let me draw 4 diagrams for you. Listen. It's not given now. I have to draw. This is the bullseye. The center is the correct answer. So if I'm repeating the test, every time I'm getting the same result and that too correct. है ना? So I will say here, ma'am, accuracy is present and precision is also present. Accuracy means answer is correct. It's in bullseye. It's in center. So answer is correct. And every time it's same. It's approx little bit here and there, but every time it's same. So precision is also there. So answer is correct also and repeatable also. The best test. We want this. है ना? The second thing you see here. You see here. So every time you are getting here something like that. So you will say, ma'am, answers are not correct. You should get it at the center. So answer is not, instead of 120 by 80. So here every time BP is 120 by 80. Every time you are measuring it's 120 by 80. Every time, every time, every time. So it's correct also and it's repeatable also. Correct also. The value wise it's correct and repeatable also. Okay, ji. Anna. Here I am getting every time the result 140 by 90. But actually the BP is 120 by 80. So every time but I am getting the same. So you will say, ma'am, here accuracy is not there, but precision is there. Precision, it's repeatable at least. Wrong is sahi, lekin repeatable hai. Bhale wrong hai, but repeatable hai. Repeatable hai. Got it? The third possibility, hai na? Okay. One time I got the result here, one time here, one time here, one time here, 2 times here, one time here, one time. Every time I'm getting dispersed. None of the test is repeatable. None of the test is repeatable. Every time different answer. Kabhi 120 by 80, kabhi 140 by 90, kabhi 130 by 60, kabhi ye, kabhi wo. So precision is absent. Repeatability is absent. But at least 1-2 results in the center. So accuracy is little bit there, but precision is absent. Hana? Got it? Got it? And the last you got it. Hana? None of the dot is falling at the center. So accuracy is also absent, precision is also absent. How many of you got it? How many of you got it? This is the best way I can explain you. Hana? Accuracy and precision. Accuracy and the sahi answer, correct answer, the validity. Accuracy is known as validity. How many of you got it? So what is accuracy? Accuracy is the validity. Hana? What the test Hana intended to measure, the test is measuring that only. The test measures what is purpose to measure. I want to measure blood pressure. It's 120 by 80. So test should measure that only. Test should not here and there should measure anything else. So that is accuracy. Accuracy or validity. One and the same thing. First learn validity or accuracy एक ही होता है. It's same. है ना? The formula you can see. है ना? The same I have drawn. You can see this is accurate and this is precise. Both accurate as well as precise. This one is precise but not accurate. The answer is not at the center. So it's not accurate, but it's precise. It's reliable. It's precise. Got it? Accuracy ka formula A plus D upon A plus B plus C plus D. Okay, please learn. No one will ask, but please learn. It is given. Okay, just a second. Okay, got it? Hannah? So that is the thing. And precision, learn the other name. It is repeatability, is consistency, reproducibility, reliability, repeatedly the same result. The test gives the same result every time we repeat, whether right or wrong, but the same result. Same result. Okay, so that is the precision. So we will do some questions based on that. Listen, what is reliability of a test? Read the 4 options. Tell me the answer. It measures what is supposed to measure. This is reliability. It is able to correlate, predict the presence of the disease. It is able to correctly exclude the presence of the disease. It yields the same reading or same value when repeated under same condition multiple times. What is the correct answer? What is reliability? Also known as repeatability, also known as reproducibility. Reliability, repeatability, reproducibility, also known as precision. What do you mean by that? None of Aditi, you are right. Yes, reading is same. Yes, every time same reading. So correct answer is D. Okay, correct answer here is D. And you all are right. Okay, G. If I change the question to accuracy or validity, what is your answer now? Validity or accuracy? What is validity? What is accuracy? From the same 4 options. So it is the exact answer which you are intended to test. I know. What is the answer in that case? I'm waiting for your reply. Yes, yes, Aditi, absolutely right. All others are also right. No, not B, Sheikh, Navjot, what you people are saying. It measures what it's supposed to measure. The correct answer in that case is A. It's able to correctly predict the presence of disease, exclude the, this is positive predictive value, this is negative predictive value. This is accuracy and this is repeatability. I can change the question 4 times. Correct answer is A. The last question, and I will pack after that. Listen, I'm having 4 sphygmomanometer. Have you seen an instrument sphygmomanometer? I guess everyone have seen, है ना? BP लिया है, BP का instrument को कहते हैं sphygmomanometer. I'm having 4 with them. 1, 2, 3, 4, है ना? So with each sphygmomanometer, I'm taking my BP 3 times. With the first sphygmomanometer, these are the 3 values. With the second sphygmomanometer, these are the 3 values. With the third sphygmomanometer, these are the 3 values. And with the fourth sphygmomanometer, these are the 3 values. My actual BP is 120/80. है ना? So tell me, 4 sphygmomanometer, you do the match the column for them. We will take one by one. See the first sphygmomanometer. Every time it is measuring 120/80. So actual BP is also 120/80. Yes, it's accurate. And it's precise also. Every time it's repeatable. So I will say it's accurate and precise. I will match 1 with C. It's accurate as well as precise. है ना? Second one. Every time it is giving different value. है ना? 140/96, 108/62, 96 by, or in none of the values correct. My actual BP is 120/80. None of the values correct. So it is not at all accurate. है ना? But every time it is not at all repeatable also. Every time different value. So it is imprecise and inaccurate. है ना? Imprecise and inaccurate. I will do 2 with B. है ना? 2. I'm sorry. मैंने गलती से कर दिया. Yes, I'm right. It is imprecise and inaccurate. No precision, no accuracy. Yes, 2 का D. Very good. है ना? Let's match with C. Third पे आ जाओ. 140/90, 140/90, 140/90, 96, 96. So every time it is measuring wrong. My actual blood pressure is 120/80, so it's not at all accurate. But every time it's repeatable. भाई wrong ही सही, लेकिन हर बार repeat तो हो रहा है ना? So it's precise but not accurate. Say it's precise but inaccurate. Say precise and inaccurate. And lastly, every time you can see one of the value is correct, but other 2 are wrong. So it's accurate but imprecise. Repeatability is not there. Now you do match the column. जो भी है. Got it? Give me a thumbs up and end the session. Thank you so much. Okay, can we end? How was the session today? Don't forget to give your feedback to the team also. They will ask you. So whatever is your genuine feedback, if you are hesitating to tell me, you can tell regarding the speed, regarding the content, regarding everything. Okay, thank you so much. See you all tomorrow morning, 9 a.m. sharp. Hannah, and I will be starting with preventive obstetrics and pediatrics. Don't miss the initial portion. Start from the beginning. So I want every one of you to come on time. Okay, I will share the annotated version with the team. Thank you so much. Bye-bye. Good night. Have a nice day. I'm ending the session. Meet you tomorrow morning, 9 a.m. sharp, 9 to 6 again. Bye-bye. Okay.